Hallo, hallo. Oh, es funktioniert.
Good morning.
Good morning, good morning.
Welcome to the Siemens Research and Innovation Ecosystem Conference, Circularity Enabled by Technology. My name is Constanze Welter, and together with the whole Siemens RIE team, I want to let you know how honored we are to have you all here today. It is a topic we are all interested in. It's a topic which got increasingly visibility during the last month. Circularity. We cannot continue like we did, and we have to have a revolutionary change from a linear economy to a circular economy. So what is it today we are doing? We are trying to close the loop. That's what circularity is about. And we can't do it alone. And that's why here in this room we have a lot of expertise from FAU, TH Nuremberg, from Fraunhofer, from ZOLLHOF, and of course also from other industry partners. I've seen Scheffler is also here, welcome. And we are very, very happy to have you all here today, and we are looking forward to have another conference where we bring together science and business, and where we really get some inspiring sparks. And I hope you all are using also the breaks for networking, finding fellow circularity friends. And, now I would like to hand over to Johanna Wille. She's in charge for the partner management and the leader of the talent programs of the ZOLLHOF, one of our partners in this ecosystem, and she will lead us through the next hours. And I'm very happy, and thank you very much for doing that, Johanna. And you have fun.
Well, I mean, thank you for choosing me to guide through the session. I'm very far away from being a professional moderator. I'm my day job. I'm a partner manager here at ZOLLHOF. I actually want to be here, or I wanted to be, or I said yes, because I'm super passionate about this. I know the Siemens Research Innovation ecosystem truly shaped my life. Because I did work for Siemens in the past, and my dear friend Ilaria invited me once to a nice event that was facilitated here. And I learned also throughout my Siemens experience that ecosystems are super important, and that's also what we believe here at ZOLLHOF. Like, we bring together research, corporates, entrepreneurship activities, startups to kind of really create the best out of the best. And also in my role here, this is what I'm doing. So I'm strengthening the Siemens Research Innovation ecosystem on a daily basis. I organize events and programs that drive innovation, but also bring people together to work on technologies, for example. And I'm also supporting students every day to work on a real-life business challenge and through design thinking. So, but enough about me. You're probably interested in what's happening here today. So we have, so the conference is divided into 3 major parts. So the first part is about kind of like setting the scene, giving you a high-level overview on what's happening on research perspective, but also industry perspective. And we're gonna end with a fun game of buzzword bingo. The second part of the conference is a deep dive of how research can be applied in the field. So we will have some tandems there, so people from research and industry both together on the stage. And the third part of the conference is like some inputs, how crucial also the ecosystem is to make everything work here, because we can't do this alone. And for that, we have amazing speakers, we have startup pitches, we also share amazing opportunities for growth, so stay here until the very end. But that's just what happens here upstairs. In the ground floor, we have a marketplace with cool demos, showcases, and also the place where we have later on lunch. Just a tip from my side, make today count. So Today is really about networking. Raise your hand when you have any question that you want to ask to speakers. You have the chance after each keynote just to say, here, I need to ask this. But you also have the breaks to get to know someone new, and maybe you find the one person that's going to change your career today here. So don't be shy. Today is not the day to be shy. Talking about speakers, actually, I would like to invite the first person on stage, and that would be Markus Beckmann. So please come up already. He will set the scene for you. He's not only a professor and shareholder for corporate sustainability management at FAU. I mean, obviously you can see he's from FAU. But he's also an expert in the field of business ethics. And today he will talk about how technology and innovation can create ecosystems for circularity. Thank you.
Thank you very much. Thank you, Johanna, for the kind introduction, and to everybody for having me here. As you already said, my name is Markus Beckmann, Professor for Corporate Sustainability Management at FAU, and I'm really excited and also a bit nervous to give a keynote at such an exciting event about circularity. Now, before we get started, I learned from the organizers that we have diversity in the room, also regarding the clicker doesn't work yet. Maybe I need to take this one. Regarding the knowledge level in circularity. So there are some experts, I already met many of them, even with PhDs in circularity, and some newbies who like the concept but are willing to learn a lot. So on that range, where would you rate yourself? If here are the newbies and here are the experts, make some noise. Newbies. Advanced or beginners? Advanced. Experts. Wow, we've got lots of energy and diversity here, and I think that sets a perfect stage for great conversations. Now, I want to set the stage with 3 questions. First, why? Second, what? And third, how? And we all know from that famous TED Talk, always start with why. So why circularity? Well, circularity is not just a buzzword, it's a response. It's a response to the limitations of our current economic model. Now, most of us know our current economic model mostly is still linear. We take, we make, we waste, we extract resources, we turn them into products, and then we throw them away. Now, that has several critical shortcomings. First, if we always take resources that are finite, we will run out of them. Look here at the graph where you see the increase in material consumption over the past 40 years, or 50 years. We have increased material extraction from a staggering 30 billion tons a year in 1970 to more than 105 billion tons of material last year. That is material that is scarce, that is finite. And if we need that material in the future, at some point it will run out. This is already creating increases in prices, price volatility. It's an issue of resource dependence. If you look at the EU, 60% of our imports or of our fossil fuels and metals are imports. And we want to secure the resource base of the future. And that is a critical topic, not only in batteries, but also in other regards. So resources are getting scarce, but take, make, waste is also a driver for the triple ecological crisis regarding climate change, biodiversity loss, and environmental pollution. Did you know that 55% of greenhouse gas emissions come from the extraction of raw materials and 90% of biodiversity and water stress? If that is true, it even gets worse when we look at the pollution. Take plastic, for example. What you see here is global plastic production. It's projected to double by 2060, but so far only about 10% of that is recycled. Twice as much of the amount is mismanaged. It goes into nature and it accumulates, for example, in our oceans. Here you see the projections for macroplastics in our oceans, and if we don't change course, within the next 15 to 20 years, we will double the macroplastic in our oceans. So that's bad for the ecology, but it's not only an ecological problem, it's also an economic problem because we are wasting value. Go through that chain. We dig out raw materials. We refine them to metals, create precious high-performance materials like alloys, put them into parts, create products, and at each step, we include capital, labor, energy, and add value, and at the end of the process, we have valuable things, and we throw all that away. That is a huge waste. If you look at plastics, there are estimates that only 2% of plastic packaging is recycled to high quality, which would equate to an annual estimated loss of 70 to 100 billion euros a year that we just throw away. So here's the exciting part. We're coming together here to change that, and if we do that, circularity can turn waste into wealth. It can reduce costs, secure resources, reduce geopolitical risks, strengthen supply chain resilience, and more, it can be a driver of the next generation opportunities. And that is a race that's already going on globally. China is already leading in solar, PV, battery storage, electric vehicles, but is now pushing hard for circularity. That's an opportunity we do not want to miss. Would be a strategic mistake. It's really worth it to go there. So the why is pretty clear. What does it then take to get us there? As we already heard in the introduction, well, the simple answer is to go from linear to circular. We have to close the loops, but that's actually a bit too short. We have to have more nuance. Let's slow down a bit and go into a little bit of more details. Most people, when we ask them, what do you think circularity should do, they say recycling. And yes, recycling is important. But it's only one element here. If we go through the different steps, raw material extraction, we turn them into parts, and then manufacturing into products, we bring them to the customers, we use them, the linear economy stops by throwing them away. And yes, we can close the loop, and we should, but recycling is the widest loop possible. It basically just focuses on retaining the value of the material, and that is good. So far, very often we just retain the energetic value when we recover and incinerate, but that's just the value at the material level where we close the loop, and that's important. But what about that parts level? What about the product level where we embedded all that value with the labor and ideas and energy and resources that went into manufacturing those products and parts? If we keep the loop closer, more narrow, we retain that value. So a simple thing would be to say, okay, how can we repair things, provide services that the product in use retains and provides that value? But maybe I don't need my phone anymore. Well, then I can go back to redistribution, and then we can have resale markets, but that needs to be organized. Maybe my phone is still okay, but the battery is weak. Maybe I can refurbish it and just replace a part, but I keep the rest. I keep much of the value. Maybe the phone doesn't work more, but there are some parts that I can use. Then I can go back to remanufacturing and create new products with existing parts, or different products which would be repurposing. So that is the second idea, that we use things longer, that we slow the flows by keeping material in the highest value possible. And that is super relevant. Now there is a third part. Instead of just using again and using longer, we can also use less. We can narrow the material flows by increasing our material efficiency, and we often forget that. That's actually super important. We use only 1/8 of the material to produce a solar panel today compared to 20 years ago. That is super relevant. We can reduce material consumption when we design, but also when we use the product, for example, when we share. So what I want to show you here, circularity is more than just recycling. Recycling is not the silver bullet. We need silver buckshot. We need many tree plants, many seeds to plant the garden, and the potential is there. However, we are not implementing it yet. If we look at the numbers, only 7.2% of material flows last year were circular. More than 92% were not. And there is a reason for that. Because the what is clear, but there are many barriers that we have to overcome. So after looking at the what, I now want to look at the how. How do we get there? Many barriers are mentioned, including regulation. 2 we want to focus on here, and that's a great day to do that. First pillar, technology and innovation. Second pillar, ecosystems and collaboration. Let's start with the first pillar, technology and innovation. When we look at a circular model that works, we need to align the flows not only of material, we also need information that connects the different players to optimize decision-making, analyze, and we have to do that in a way that creates value. We have to have business models that work. Let's dive in and have just a few of the examples to show why it's so exciting what we're doing here today. We have innovations in the room, and we're going to share them. At the material level, we can go to the beginning. What kind of materials get into the chain? Is it multi-component materials, or is it monomaterials? Is it degradable or biodegradable? That's material science design, something we need to do, but also how to then bring those materials into the product. And here's an example of a monomaterial where we have a bag that uses polyethylene for all kinds of different layers, and then it can be recycled easily. So at the beginning, we already have to design for the end. That's also true when we look at design for repair and modularity. I talked about the phone and that problem of the battery dying. There are forms where you can just open the foam and switch the battery. That makes it easier, but you have to design it before the battery has already died. We can go to advanced recovery and recycling. Right now, many companies want to use secondary materials, but they don't find them at the quality, the cost, and the scale needed to integrate them. We need new recovery technologies, and they can be innovative. For example, looking at nature, what we will do in the afternoon here in one Tandem, we can have bioenzymes that help us recover materials and recycling. Now, what you already see is it's about treating the materials, but also knowing what to do. So a lot is sorting, aligning, and we need information for that. So it's not only what we do to the material, but also the information that informs our decision-making. So when we look at information, we can see how sensing and predictive maintenance can make a difference. The robot who sees this is polyethylene, this is polypropylene, and then puts it into different tracks of recycling, which will increase the purity and the quality of the output. We can use predictive maintenance as a service to reduce cost and avoid downtime. We can also look at sharing that data, but then we need the connectivity. We can have digital twins that simulate how we can optimize the usage and recycling and reuse of value. And we can share that information with new forms like digital product platforms and data platforms, digital product passports and data platforms, where you scan a component or product and you see that is the material that was used, that is how you can disassemble this, this is how you can repair it, this is information we need to provide. We also need to do that in a way that aligns with the ability of companies and their partners to benefit from that transition. If we do it because we think it's good for others but not for us, we will not get the leverage we need. So we need to align business models, and that requires all kinds of different approaches. We used to sell stuff, and then ownership was transferred. But maybe we need to go from ownership to access, particularly when we have those more narrow circular loops. What does it mean for pricing? Do you have a subscription or do you sell a stuff? What does it mean for revenue models? If you have investments into a more durable material now, you will have savings in the future. How do you align that with the cash flows in a company? What are the pricing models? A lot of what we focus on is not only improving the material, but the services around us and around them that allow the flows. So what about logistics? What about collection? What about sorting? What about repair? What about advice? We have to have a different mindset here. That mindset is easier said than done. If you have been incentivized to sell products and now you want to get a long-term subscription or leasing, if you've been incentivized and have the knowledge to have stuff in your hand, but you're talking about keeping information and other types of value in the flow, we need to change organizations, we need to change business models, and that is a big opportunity for us. So that was the one pillar, and I said we need technology and innovation in so many regards, and we have them here in the room. But what you already saw is and what the title of the conference implies, we cannot do that alone. I have a picture here of a dung beetle, because I think it's a cool example to show the one who produces the waste or the output and the one who uses it sometimes are very different. Different competencies, different actors, and we need a diversity of those skills. We need collaboration in those ecosystems. If you design a fabric such that 5 years later a recycler can recycle that cloth, you need to collaborate, you need to exchange information, you need to develop trust. We need companies, big ones, startups, NGOs, regulators, and all of them have to come together. And that is why the ecosystem and collaboration part is so important. So I started with 3 questions, and I would now like to summarize. Why circularity? Well, because the linear economy is wasteful, and if we change that, we can turn waste into value. What? Well, we saw that it takes many different approaches. We have many tools and principles, but it's more than just recycling. We have to look at it holistically, bring different things together. And how do we get there? By building the technologies, the innovations, together with others in ecosystems, by partnering. Now, when I looked at that and realized that I will wear an FAU hoodie, I thought this can actually be captured in the values that drive us at FAU, but also our partners in the ecosystem. The what can also be translated into passion. We have a passion to create a better economy and a more sustainable future. And we need innovation to get there. And that's innovation, not only technology, it's also mindsets, it's business models. And we don't do that alone. We do that with a diversity of partners, of Siemens and Ohm and ZOLLHOF and Fraunhofer and all the startups, with the different approaches we have in our toolkit for circularity. And if we do that, I think we have a wonderful reason to be here today. We have all of that ecosystem diversity in the room, so let's leverage that diversity with a passion for us to create the innovations we need for circularity. Thank you very much.
And also thank you, Markus. I hope you're later on also here to answer some questions. As a next speaker, I would like to get Andreas Mehlhorn on stage. He will give an overview from an industry perspective. He's the global head of sustainability at Siemens Mobility and has a strong background in IT and business development. And what I think is super cool, he's also an advisor and investor for startups as well as small and medium-sized businesses. Thank you. Come up.
Well, first of all, dear community, happy to be here. Thanks for the invitation. It's the first time that I'm here. It's a little bit of shame. I will come more often. I'm really pleased to give you some insights into how we as industry look at it, but also listen to how the others look at it. And just listening to Markus, it's not so different. So we have quite a lot in common. Let me start with a personal note. I mean, during the first 20 years of my time at Siemens, circularity was more or less seen as a waste management topic. And you know, being a high-tech company, waste is something that we don't like. Be it material waste, be it process inefficiencies, or be it organizational slack. So we're always a company, you know, doing automation, digitalization, where waste is something that we would like to avoid. But looking back, it seems that we somehow also overlooked a little bit the systematic change, especially in the last 5 years, that came with the need to change from the linear models to the more circular models. And now, since I'm 2 years now in my new role, being the head of sustainability, circularity is one of the top 3 topics on my desk every day. And what's more important, it's a topic where I can bring my former community, the business community, together with my current community, the sustainability community, because this is a topic where sustainability, resilience of supply chain, but also cost efficiency comes together. And I think if we get this right, and I think that's the topic for the industry, then we can more often say it's sustainable, efficient, and resilient, and less often it's sustainable, but not really economically viable. So I think from an industry perspective, in a nutshell, it's decoupling growth from resource consumption. That's what it's all about. Let's dig into, and as Markus, I have 3 parts with me. The first is why, but specifically with an industry perspective. With an industry perspective, a little bit focused on mobility, but you can transfer it to other industries. Then the what, so what needs to be done to unlock this opportunity? Because it's good to have an opportunity, but if you cannot unlock it, especially also for business, and we need to unlock it at scale. So we cannot go just for anecdotes, pilot projects. The question is, how can we unlock it at scale? What do we need? And the third part, the how, I brought 2 examples from day-to-day business. How do we translate this into offerings for our customers? And have 1 example fresh off the press, what the digital offerings that you need are looking like. Coming to the why question. It's not so difficult. Looking at our industry, mobility, rail transport, heavily embedded in Erlangen-Nuremberg and in Munich, it's a growing mobility demand. That's for sure. End customer is growing 2-fold, 3-fold. So of course the question is, if the end customer demand is growing, in the B2B arena you have clear investment needs. In infrastructure and of course in rolling stock. The first, and I think Markus already mentioned this, it's already an industry where efficiency, resource efficiency plays a major role because tough budgets have always been there and relate to cost efficiency and to performance. But during the last 2-3 years, we also saw that our customers are putting ESG and circularity requirements into the tender. And I just come back from a meeting 2 days ago with my UK colleagues, where in a tender, it was TransPennine, the customer explicitly asked us, you need to provide an end-of-life disposal plan, full stop. So that wasn't there 3 years ago, and we need to have an answer on this. But that's just the first part, and I think what Markus already elaborated, now comes to scarce materials. Looking at the materials that we need, the critical ones, aluminum, steel, copper, electronics, they are going to be scarce. So the demand is rising, the supply cannot keep up with this demand. And in addition, the minerals and materials come from areas where we most probably find geopolitical risk. So we have a situation where prices are rising, and where also the risk of getting these materials is increasing. This holds true for all materials, but especially if you want to decrease our Scope 3 emissions in our supply chain, we need to go not only for these materials, but for secondary materials, which have a much lower footprint, and for green materials. So that's even increasing the topic. And as Markus already said, we do this in an arena where most of our ESG challenges are increasing. It's not only about CO2, it's about biodiversity and so on and so on. So that's quite a tough situation. The question is, how can we manage growth and still do it in a cost-efficient way, in a way that we can have resilient supply chains, and in a way that we do it in a sustainable way. So that's the situation. And as Markus said, there are in a nutshell, 3 key things that we need to do. Doing more with less in the first phase, when we design products, when we design offerings, lifetime extension, when the product is in use, and value recovery, which doesn't mean incineration. It's really value recovery at the end of life. And for us as industry, it's a challenge, but being a technology company, it's also an opportunity. So if we do this right, we can grow sustainably and profitably. Let's have a look what is needed to do this. And no surprise, there are 3 success factors from our industry perspective. The first is technology is an enabler and also an accelerator for the entire development. As Markus already said, it's both physical and digital. Material science is coming back as a major topic with circularity, but also the IT, the digitalization topic, and the AI topic. Looking at our trains, we need to go for secondary materials. Customers is asking for 30%, 40% secondary materials in our trains in 2030. We need to go for eco-design. We just got an award for a bionic design of a car body, which has 30% less weight. So these are things we need to go at the very beginning. But also looking at how trains are designed and I just can quote you, we need to have digital twins for our train design. So why do we design trains from scratch every time? So by doing this with digital twins, we can also avoid resources at a very early phase. But then when it goes on, in the use phase, data ecosystems are important, because if you want to manage circularity, you can't do this alone. You need to cross value chain. You need to have platforms to do this. AI plays a role, because at a certain point of time, you need to define, and Markus showed you already the R strategies, which R strategy is suitable at which time. What do you do if a train is somewhere in Paris? Do you refurbish? Where are the parts? What are the prices? So this is something where you need decision support, and AI can play a role. Additive manufacturing of certain parts, but also end of life. This recycling process, and I just come back because we signed MOUs both with TRS Remondis and Suez. This recycling process for our industries are not yet good. So they are still done in a very inefficient, not automated way. We need to get better there. Trains are just cut down in pieces, no matter what technology is in there, and somehow it gets back somewhere. But it's not efficient, we don't take the technologies out, and that's something that we also need to improve. Technology matters, it's an enabler, an accelerator, but it's not all. What we need to do is operating and business model. We need to get deeper into these R strategies. How do we do repair, remanufacturing? But that's just a technical part of it. There's also a business part of it. We need to understand, given our DNA, given our margin bands that we have, we need to understand how to make money, how to add value out of this process. And therefore, it's operational model, the R strategies, but it's also business model. Now, how can we increase lifecycle services? Because as Markus said, if you sell a product with lifecycle services in one package, it's much easier to do circularity than if you just sell it and then somehow does the rest. It's about marketplaces that we are going to build up in order to make a place for reselling materials, a place for reselling components that are used. It's product as a service. I'll show you later that we just started a startup which is focusing on leasing battery and hydrogen trains. So this is a part of operation and business model. But if you look at it into more detail, a lot of the things that you need are not in our DNA, especially when you look at the end of life. So you need to set up ecosystems that allow you to close the circle, because you can't do this alone, and it would not make sense DNA-wise, competence-wise, but also value pools-wise. So therefore, ecosystem to close the loop is key. And some of these ecosystems are within current value chains, but some of them are out of existing value chains. And I can tell you, the first time when I came back to my organization, told them we need to discuss with recyclers. For a high-tech company, that's something which is not in our DNA. But talking to these colleagues, that's quite something going on at the moment. I'm not sure if you read the news. TRS Remondis, one of the big recycling companies, is interested into buying Salzgitter, or large share in Salzgitter. And by the way, that also includes Arubis, copper. So there are new industries developing, and we need to be part of it as an ecosystem partner. Not owning these activities, it's not part of our DNA, but we need to be part of it. So that's a little bit the ingredients, but just having the ingredients doesn't make a good meal. So the question is, how can we translate this into business? And I just brought 2 slides. The one is what we have done the last 12 months. We have talked to around 50% of our customers to understand where's the concrete demand. And yes, it's exactly this mix of cost efficiencies. They need to have trains longer in use because budgets are tough. And in addition, sustainability. We looked at ourselves. Where are we? Are we at the beginning? Are we already there? And we found out that we already have a strong life cycle footprint, which we can use for circularity. Not fully covered all of the things that we discussed today, but quite something there. We understood that we need an ecosystem to close the loop, and we also understood that we need to find out how this thing works. Who needs what? What are the business model? How can we do it profitably? And again, here, we're not going to go just for pilots in order to be part of the circularity hype. We need to do this at scale if we do it at industry. So therefore, these were the ingredients. And just look at this slide. So we found out that our customers, need 3 packages at different stages of their interaction with us. In the first place, we need to really offer the development of trains and infrastructure in a way that we use these eco-design principles, but also digital twins. That's something that we have, that we are strong with as Siemens. We need to do more with less, meaning we need to integrate our digital offerings, predictive maintenance, to get the same performance out, but with a smaller train fleet. Because if you can predict how maintenance will look like, you need less spare trains. That's something which helps. And we need to go for more as a service model and less selling models. That's just at the beginning where we can add value. If it then comes towards the use phase, it's all about refurbishment, modernization, upgrades. Yeah. As you saw on the last slide, of course, our market is growing, but also our operators need to extend lifetimes. So you need to be there. What does lifetime extension mean? What kind of services we need to offer? It goes down, when we say end of life in our business, it goes down to 5 years. You know, our customers decide they want to phase out a train series. So probably it's a 5 years process where you do repair, where you do also technology upgrades. And at the end of life, you can also do something when it comes to spare parts, when it comes to platforms or secondary materials. And we just built up a platform where operators can sell their excess parts that they have on our platform so that it gets back to the systems. We also have set up this platform to sell secondary materials so that the materials will stay in our industry. Why do we do this? Of course, because we are part of this industry that needs to work, but also it increases the stickiness that we have with our customers. And then, of course, the most difficult part was this last phase. How do we get into this value recovery services, component materials? And just to give you a number, we made an analysis. All trains that are retiring in 2030, how much material this would be. I can't tell you the exact number, but we could get up to 50% of the materials that we would need to build them if we find a way to get these materials back. Quite interesting. So that's the way we go. And just a little bit of advertising. The World Economic Forum also endorsed this approach as a best practice and will launch this in Davos in 2050. So that's the way how we see the entire package, but there's one thing that I'm also proud and also interested to share with you and to discuss with you is the digital part. And that's also just fresh off the press, because yesterday the German government awarded us a project that exactly focused on developing the digital elements for sustainability with a focus on circularity. Other industries have already done this. You probably know Catena X from the automotive industry. You probably know Factory X from the manufacturing industry. Now there's a new kid on the block. It's called, at the moment, Railway X. There will be some changes happening. My team is going to lead this, and very interesting, look at the use case, exactly what Markus said. It's about the digital battery passport. It starts with batteries, but it will extend to all other materials too. Because if you don't have the materials at the beginning, if you don't have a battery, it's hard to do this R strategy. It's hard to do recycling at the end. You need to have this information. Product carbon footprint, real data across the value chain. Traceability of parts, otherwise there's no secondary market, there's no secondary use if you don't know, especially in our industry, whether products have already been used. AI, we're developing together with the German Deutsches Institut für Künstliche Intelligenz, an AI solution for circularity. And, you know, of course, below all of this is a joint industry-wide IT and data architecture. These are the partners. You see again, I don't have to repeat ecosystem, you just see the partners who are there. We have the industry partners, and we have, of course, also the operators, because we need to have guidance from the customers in order to do it right, because we are not going to do circularity because of regulation, we are doing circularity because of customer demands. And therefore, we have them on board too. So that's very interesting, stay tuned. It will take 2 years in the first phase, and then we will go on with implementation. To sum it up, my perspective is I love circularity. That's where my former life and my current life met. This is where business and ESG meets. If we do this right, we can really do this triple win strategy. Technology is an enabler and also an accelerator of the entire discussion. Interestingly, it's hardware and software. You can't do it only with one of these technologies. Key message from my side, it's end-to-end customer focus. It's not regulation, it's not doing something here and there. You need to understand your customer end-to-end in order to come up with circular solutions, including the operating and the business model that we just discussed. Very important is, when these new topics come up, we often go all for pilots and do anecdotes, and after 3 years, there's a new kid on the block. We need to do it at scale. We need to jointly find out what works. Therefore, we need pilots. But at the end, we need to do it at scale. And we can only do this if we close the circle with ecosystems that are sometimes within our current value chains, but sometimes, especially when it comes to end of life, they are out and beyond our current ecosystem. And we need to understand how these colleagues work, how we can jointly grow. Because if we get this done, then really we can decouple growth, which is our industry goal, and also the goal of societies, with sustainability and also with a resilient business. Thanks for your time. Looking forward to the discussion.
Also, thank you, Andreas. So next up in our agenda, we will play a little game. And for this, I would like to invite two amazing personalities on stage, and that would be Dr. Roland Busch and also Professor Joachim Hornegger. Roland, for the ones who don't know him, he's the CEO of Siemens, and that means he's steering a global powerhouse that really transforms the everyday. And that's really like a huge company that can bring together the digital and also the physical world. And I think that's pretty damn cool. So I'm happy to have you on the stage. And the second person is Joachim, who worked in his career for various renowned universities and institutes, like Stanford, Harvard, and the MIT. Now he's the president of the FAU and has a passion for research and also supporting young talents. And I feel like we have another overachiever here on stage with you. Thank you.
Hi.
Another fun fact that I didn't know about the both of you, now you're curious, is that both of them actually graduated from FAU, so they used to study there, and also both of them worked at Siemens. But I want to come to the fun part of this session here, so I want to see how much you enjoy the board games. Because, board meetings you're used to. So let's see if you can use that experience into practice here. So how does it work? We prepared a couple of buzzwords and around circularity, and I will reveal them one by one.
Mm-hmm. Okay.
Your task is to briefly explain what comes to your mind. Just a few sentences. Time is key.
Time is key.
Time is key. And we do this one by one. So, Roland, you start with the first word, and then it's your turn. You continue with the next one, and then it's you again. And whose turn is it then?
Yes. You expect useful comments, or?
Whatever pops up to your mind. Maybe we also have a few fun keywords included there.
Okay.
Okay.
Who knows?
I'm nervous.
So
Yeah. And last time there was the buzzer. Today this is the buzzer. So
you're the buzzer.
I'm the buzzer. Yeah, but
Okay.
please don't press me. Okay, let's give it a go. So, there's no music in the background, so I'm going to be the music. The first word for you is simulation.
Simulation.
Yes, spotlight. What comes to your mind?
You heard it. I do believe that if you really talk about a circular economy, you have to start at the very beginning. So creating a digital twin of a product and simulating how you build it, but also how you would disassemble it, simulating what's your footprint in the very first place, and maybe also simulating what kind of different materials you can use. Can you use recycled material? They are a little bit different. You can simulate it. That would accelerate the whole process on the one side, and the other side, you really embed circularity from the very beginning. So
I get why you
okay.
CIO, yeah. All right,
That's
next
me.
one. That's you. AI in circularity. What do you think?
Well, as an AI expert, I have to say it's very important. It's crucial. You know, AI can, first of all, learn from all the different sources of expertise, and AI can generalize, so you can use it as a decision-making tool to give higher insight into links that you don't see. And I'm pretty much convinced that AI will support you in process design and all the different loops that you have to close within circularity. AI is a wonderful tool, and I hope that the algorithms that are going to be developed in the near future will even support way more than the currently known ones.
As I said, overachiever, like on point.
Oh, try.
All right, next one, automation.
Well, a couple of things come to my mind. Reading circular economy backwards, I think we have to think about how to automate, get the materials back into the value chain, because if you spend more energy or cost in collecting, guess what? Business model will not fly. The second one is, we heard it also earlier, that we are coming from an economy which was optimized over the last 100 years. It's a one-way street. Running it backwards, it makes really you need a little bit of rethinking. And one is how to disassemble, how use automation to disassemble parts. Obviously make it less costly and faster and getting access to the value. That's something what comes to my mind when it's about automation.
Yeah, I mean, automation is for sure like a home play when it comes to
Yeah, we know that a little bit.
Yeah.
Indeed.
All right, another one for me. That's good, that's too easy.
We know that a little bit. Well, research is linked to universities. Of course, it's in our DNA, but it's important. I mean, like the economy changes from a linear to a circular one, also research is changing a lot. And the way we do research, it's much more important that we have an open-minded research environment, that we collaborate with our partners, that we have a strong ecosystem. And with the RIE here in the metropolitan region, I think this is a very, very good example how research of the future should be done. It can only be done together over the various partners and collaborations, and diversity is key.
Absolutely, fully agree. Next one, decarbonization.
Yeah, well, it's easy, no? Because I mean, if you use recycled aluminum, I think you save 80% of the primary energy. So that's the answer already. It's more than that. It's not only decarbonization, but it's also increased resilience. For example, it's getting harder and harder to get access to certain materials. Therefore, also it's more costly. And I do believe that circular economy plays a substantial role in really achieving our decarbonization targets. Also, in particular, in the Scope 3 upstream area, which is a big one.
It is a big one.
Yeah, it is. I mean, give you an idea. Our Siemens is a global company. We are less energy intensive. So our global footprint, Scope 1 and 2, is 500,000 tons. If you go to Scope 3 upstream, we are talking about 10-ish, 15 million tons. So therefore, it's a factor, it's a magnitude bigger. So therefore, it's a topic, yeah.
Next one, we also have a lot of students in the room. So,
Of course.
I said you have a passion for developing students.
I mean,
That one
key
is
for
for
the
you.
future is to attract the talent and to educate the next generations of leaders and solution providers. And I think at our university, the topic sustainability and circularity is well positioned. We have had some strategic hirings, as you have seen Markus, who was very strong in this particular field. We have many more new professors, and our focus of our programs is really linked to the future and to educate the leaders of the future to address those problems that are very demanding for our society. And our international visibility is high. We are increasing it way more, and the fact that we have many students here is telling me at least that we are choosing the right approach.
All right, last one due to time, and I have another question later. So I want to know, what is your personal sustainability hack?
So, Well, I mean, no, you would expect me to say, rather than driving a car, use a bike, or if it's a car, go electric. Use your stuff longer. Don't buy stuff which you wear just one day, throw it away, but use it longer. But I don't. So, because for the very same reason I was talking about it, this would affect your own personal footprint. What's your contribution? But if you study circular economy and if you have a lever on products which scale in the world, the impact you can generate is 1,000, 100,000 times bigger. So my hack would be study real stuff. So it's kind of circular really, and this is, I think, and it can be digital technologies, building digital twins. It can be automation. It can be any kind of also specifically recycling, even how to develop ecosystem. So it's a huge area, and I do believe it's also good because you will get tailwind.
Thank you. My personal one for today is actually I didn't have a stage outfit, and I have a friend who is very fashionist, so I asked her if I can lend her outfit. So that's my personal one for today. And I have a last one for you as well. Erlanger Bergkirchweih. That's probably a place that you know.
Of course. I mean, talking about attracting students and talents, this is the best argument for sure. But the Bergkirchweih, of course, is closing the loop in many ways, so it returns every year. So that's good. So get used to it.
This is a very
what's not implemented at Bergkirchweih is that you get more beer for less money. So it's vice versa. So we have to fix that. But just kidding a little bit, but it's also important that for our ecosystem and the way we collaborate and interact, Bergkirchweih is very important because you meet students, you meet professors, you meet lecturers, you meet representatives of industry. Everybody is at the Bergkirchweih having fun and talking to each other, so it has a high value for our region and our local ecosystem.
I thought you would mention the Riesenrad and when you're circling people all the way.
Oh, as a physicist, you know that depends on the speed as well. No.
Amazing. And with that, this game has ended already. And I do have one final question. And that would be, if you could implement one innovation that has like an urgent need of action, and you would do it now, immediately, what would it be?
Oh, wow. I mean, put it that way, since I believe that, and you can, if you make a study on disruption, when technology was disrupting a market, very often people are saying that the incumbents failed because they didn't really have the right technology. I mean, like Kodak, for example, they completely missed the boat on digital. I believe it's only half the story. The other half is the go-to-market and the ecosystem, the partnership. So and since innovation is bringing an invention successfully to the market, my wish would be that a kind of a ecosystem emerges quickly, which is really carrying all the ideas which we have into the market and make a business model out of it which works. Because at the end of the day, if you don't make money out of this idea of circular economy, it will not fly. As people don't really, at the end of the day, they don't pay more for a sustainable product. So you really have to make it economically work.
Mm-hmm. Yeah, true.
For me, it's important to work on speed and the speed also we change and adapt to the global changes. I think that is very important. And if you look at the role of the universities, it's also important that universities change the way they interact within their ecosystem, and that should be done way faster than it is happening today, actually.
Thank you. So what do you think? How well did they do? Very good. Yes. Well, big thank you to the both of you. For me, it was a lot of fun. And we're going to continue now with a short break. And we will be back at 10:50, so around 20 minutes. And then we continue with the second part of the conference.
Thank you.
Thank you. It was fun.
Welcome back, everyone. I would love for everyone to get a drink, maybe a snack, and get yourself seated again, because we are ready to take off. I see already people still making pictures here because we have true celebrities. All right, welcome back. I hope you enjoyed your break. Now we'll start with the second part of this conference. And in this first session, Tandem session, you will learn what the modern circular process industry adapted and learned from Mother Nature. And on the stage, we have Professor Bastian Etzold and Dr. Christoph Kiener.
Hi.
Bastian is an expert for Power-to-X technologies, and he's also part of the Department for Chemical and Biological Engineering at FAU. He's not wearing a FAU hoodie, but I think you can still, I don't know, like it's going to work. And he's also having a Bavarian distinguished professorship. Maybe he can also talk about this later with you in the breaks. And on the other side, we have Christoph here. He's the principal key expert at Siemens, but he's also active in academia. So I feel like both of them bring academia and industry perfectly together. So I'm happy to hear your speech.
Thank you. Yes, Christoph, great to be here. Do you remember how we came together and how we met?
Yeah, so I didn't meet you 3 years ago, or I didn't know you 3 years ago, but we met then in our funded project 3D Process. So the FAU is not mentioned here, but you've been a subcontractor to the KIT team because you have these perfect methanol substance data.
Yeah, also KIT needs support from time to time, yeah?
Yeah. And I think this was in Berlin 2022 in the evening.
Yeah, we had a marvelous evening, a business dinner during the project meeting. We sat together and I think we chatted for 3 hours or so, and we realized that we have the same language and thinking, but shared, we can use the competence of the others, yeah? And this is where our collaboration started to intensify, and happy that now here we present what came out of that. Yeah. Christoph, the topic of the project, but also of today is somehow circularity enabled by technology. How are you connected to this topic?
So to be honest, this influences me already for quite a long time. So this goes back to the time even when I was at school. And we have even some pupils here, I just heard. So this can be important, what you do as a pupil and what you also already think at school. So I was influenced at that time in the late 80s, the early 90s by these environmental movement and environmental topics coming into society. And then in my last year in high school, I found this book here, and this is really the original one which I took from at home. So this survived, and we didn't throw this away. This is also kind of sustainability. Yeah? And this was to the 30th anniversary of the book *The Limits to Growth* of Dennis Meadows and Donella Meadows and a team from the MIT, which is widely known. And well, they were drawing future perspectives or outline future perspectives, how the world might change, and had these hypotheses that there will be nearly a peak in everything, and this somehow scared me, and I started to think, can we do something against? What would be the right measure to keep a certain lifestyle and not drop into these catastrophes which they projected? And I was then really excited that I managed to meet Dennis Meadows in person once at a resource conference in Pisa, which was in 2005. And this guy is really an inspiring person. So at the age when he wrote this book, he was just 30 years old at the MIT. That's the reason why 2005 he was just 63. And this influenced me a lot. So, but how was this with you, Bastian?
Yeah, let me explain you. What you see here is the beautiful view from the Schorchenspitze. A picture from this year where I was hiking with my dad. I'm doing a hike with my dad every year. And he really inspired me and gave me the fascination for two things. So here you see him. I think he's probably also online. Hi. The two things is, the first thing is the fascination and love for nature and how nature is doing this. Yeah, how nature perfectly is doing circularity. The second thing is also the fascination for technology and what we can do with technology. So here you see a little bit older or younger me and older picture, which is at Jugendforsch, not too far away in Erlangen in the Heinrich-Lades-Halle. Already at that time, it seems like computer fascinated me. There's something 1998 computergestützt aktualisiert at that time. So these two things, nature and technology, somehow are important principles for my life. And let's have a look. How is doing nature circularity? Nature really takes care to close the loop very, very efficiently. The carbon cycle should be closed very good. What nature is doing, it's taking water from the soil and pumping up the liquid water with capillary forces. It's taking the CO2 from the atmosphere, which is surrounding, and plenty of them is available. And then it uses energy. I don't know who knows how energy efficient nature is, but photosynthesis only has an energy efficiency of 5%. So nature knows there is sufficient energy available. It can harvest, but it wants to close the carbon cycle very good. And then it builds off these molecules like sugar, for example, also to store energy, but also to build up the plants. Yeah? So the whole construction material is made from this. And let's have a look at a tree. Out of something like a monomaterial, we heard, going to a monomaterial really makes sense also for recycling. Nature knows this. Out of this monomaterial, it builds up somehow capillaries, which can then suck up the water, bring the water to the leaf, contact it there with the CO2 and with the sunlight to make the reaction and to produce something. But it also builds up, despite these reactors and pipes, you could say, also the construction material. Yeah? I mean, a tree can withstand a really strong storm by this design. So we have a very, very highly integrated device. For me, this is a chemical plant, but it's highly, highly integrated. That's really cool. But what would you say, how far are we with man-made things close to this highly integrated bio-inspired devices?
Now, we are not so good as nature is, but we are coming closer. And I've been doing additive manufacturing now for quite a while. And one thing what we have been looking into the special technology of laser powder bed fusion. This means melting very fine powder with a laser. By tuning these laser parameters, you can generate also structures which are porous, which have an interconnected pore system. And this means you can use this a little bit similar as what we have seen here with a tree. For instance, you can make use of capillary forces. So in CAD, you don't see any difference, but by applying different laser parameters, you can generate a kind of different structures, which have then different properties. So in a certain range, you can fine-tune these properties and can make pore network channel systems, which have then capillary properties, like, for instance, here, a piece of sugar. What is known from a piece of sugar, yeah? And just last week, there was a World Lead Fair for additive manufacturing, and I had the pleasure also to be there at the Siemens booth of Carsten Heuser's booth. And we had even Peter Körte as a visitor at this fair and saw how broad these applications and the technology has already developed. And when we are talking chemistry here, this is really something which happened here close by. So we had at our Siemens booth the company Toolcraft as a partner company. And as a customer of Toolcraft, we had Innosyn as an exhibitor also on our booth, who are already doing chemical reactors with additive manufacturing for highly reactive organic reactions, for instance, to prepare pharmaceutical materials or specialty chemicals. So other than it is here shown in the upper picture, with this classical conventional reactor where you have a large amount of liquid and then the cooling around Now the new idea is pack the reaction into a fine channel and have continuous cooling around that channel so that you can do a very much better temperature management. This works already with these highly exothermal special reactions with highly reactive chemicals, but it does not really work with these energy-related processes as we know them from refineries, for instance. So here we have still this concept of separately designed vessels and the process be separately designed and then being interconnected with pipes. So a very sequential process. And also in the realization and in the making, it's then a very sequential making. It is all brought to the construction site and then put together. But I think the target which we want to have is what is shown here, that, for instance, the catalyst is in very close thermal contact to a heat removal system so that we can optimum reaction. But Bastian, do you have an idea what would be a good reaction, what could be used for such an additive manufacturing approach?
Sure, I have. But when you show this, this is really far away what we see on the left-hand side from a tree plant. Yeah, so nature is there is really better. Let's try. Let's see how far we can come here in this lecture. So let's see how our present linear process industry is looking like. Yeah, and we have heard we take resources from Earth, and this is mainly like something like gas, oil, or tar, or coal. Honestly, things which we cannot use. I mean, what can you do with tar? Yeah, you cannot eat it, you cannot drink it. Yeah, that's really completely useless for us. But what we can do as mankind, and that's marvelous, that we can convert it to products which are of really high value for us, like the toothpaste we used in the morning, vacancies, diapers, the high-tech materials in mobile phones, yeah, or materials for the windmill. So this we make out of these unuseful products. There we are really good, but of course nowadays we use it and then we dispose it later on. And as we have heard, yeah, in the morning, either it goes to landfill or it's incinerated, so we blow CO2 in the atmosphere, which comes from fossil, somehow collected over 1 billion years. This is linear and not circular. Now let's see how can we close the loop here. And what you can do is, yeah, you need to take now the waste, and you need to take the CO2, and you need to take CO2, which nature stored in biomass, and from this we need to make our products that we want to have. So let's have a closer look in this make button here. Yeah? Let's see what there can be done. And here, interestingly, the first products which we have in chemical and petrochemical process industry are not so many. This is hydrogen, this is ammonia, this is methanol, these are the aromatics and the olefins for polyethylene, for example. Yeah, there we need the olefins. Not so many. If we manage to produce this first, some chemicals from waste, from biomass, from CO2, then we really win, because later on we can use the existing infrastructure, the existing 100 years of optimization knowledge to produce the chemicals that we need later on. So let's start with how could we produce these first products in a circular way. The first one is hydrogen, and I think everybody in the room knows that we can produce this when taking water, sustainable green energy, do water electrolysis, then we come to the hydrogen here. And if we have the hydrogen, we can do what we already do today. We take nitrogen from the air and we produce in the Haber-Bosch process ammonia. So these are non-carbon products. Now comes the circularity. We need to close the carbon loop. We need to do defossilization. We cannot decarbonize ourselves. Yeah? We consist of carbon. Our products consist of carbon. We need to defossilize them. So the carbon now needs to come from the waste, from the biomass. And if we do a gasification or an incineration, then we produce mixtures of CO and CO2. And now we need to learn how to very efficiently separate this useful carbon building blocks from this flue gas that we have here. And then we can use this CO2 and CO together with the hydrogen. And now we can produce methanol. But interestingly, the methanol plants are now different to what we are used nowadays. They must be the size, for example, of the waste incineration which we have in Nuremberg, or of the biogas plant in Fürth, because this is the size that we have here. That's different. We need a downscaling, a downsizing of the technology. It must be robust and downsized. And if we have the methanol, Now we can produce from this the olefins and the aromatics. So probably in the future, most of the carbon will go through methanol. That's different to today. So you ask which process to focus on. I say, let's take methanol.
Okay. Yeah, and this is what we really did. So we looked onto a methanol reaction system, and what happens there is we have now, not as the industry today does, carbon monoxide and hydrogen coming from natural gas, but we take as a source now CO2 and hydrogen, which means that there is also the formation of water. And so this means we have to manage these chemical equilibria, which now consist then of complex mixtures. So hydrogen and carbon monoxide together go into the reactor, and what we know them from thermodynamics, so the higher the pressure is, the better the yield will be due to the thermodynamic equilibrium. That means if you want to get much product, you have to go up with the pressure. And the reaction produces heat. That means the gas which comes out is hotter than what went in. And to separate this, well, this can be done as in a humid room. When you have the cold window, you get condensation of the water steam at the window, and the remaining gas stays in the room. This is the same we do here, but to be energy efficient, we first use this kind of feed effluent heat exchanger to take out the heat of the mixture, and then only the remaining temperature is taken out to get the liquefaction. And if this is done right, then the liquids go, water methanol goes with the liquid, and the remaining CO2 and hydrogen from the equilibrium stays with the gas phase, still cold. And to be really energy efficient, this has to be reheated up to the temperature level that it can be brought back in the next reaction loop. So it's very critical to have this separation precisely and to manage the temperatures very well. And to do this in one piece, this is quite a challenge often.
This is a challenge, and Christoph, who fully understood it, has a chance to get a certificate for a thermodynamic class and heat exchange class afterwards, yeah? Yeah.
Okay. And, well, I think conventionally it would be done in that way, that you piece by piece buy this equipment and put it together by piping. And what we thought now is, do we have, with these advantages of additive manufacturing, do we have the chance to get the piping away and just pack this together into one piece, so that we have this cooling functionality, the condensation and the reheating in somehow one part? And this is possible with these kind of porous material structures, and it's also realized in this very heavy block of metal. So you can, if you like, afterwards touch it, it's real metal. Yeah? And the possibilities now with digital design and with additive manufacturing are there. And yeah, but my question was then, how large have these things to be? This is really difficult now, because if the size is the wrong size, then this will not work. And
yeah, and
it's good to have academic support from that side.
Yeah, and what you see here is that it's marvelous. These 3 units, you can break this down to one functional key element, which we see here in the middle. And what we realized very soon is how to design now this functional key element. What is the thickness, the length, and so on of the different zones, the diameters. And as it's 3 units combined, if you change one parameter, yeah, it has an influence on all processes taking place in parallel. And this you cannot design in a classical linear engineering design. And that's why we went for a digital twin there, and that was our competency, to build a digital twin of this highly complex coupled thing, including all the fluid flow in porous media and the free media, and especially this 3-phase or 2-phase flow that we have there, and the condensation. When does the condensation take place? How many liquid can be drawn out here at completely different temperatures and pressures taking place? And we built up this digital twin, and then we looked at what is now the sensitivity if we change these parameters, what is happening. And here you see the diagrams. It's a number between 0 and 1, and this tells how much of the condensable product was condensed. 1 means everything here. And then we achieved quite well with this. We could design, together with your expertise in building up a CAD, which is completely parameterized, that we can vary in in the digital to build twin, more or less, what we have changed and bring this to reality. On the one hand, for a lab scale device, but also for a scaled up device, which will be used in reality.
Yeah, and the CAD here shown really consists of 140 parameters. This means this is a table with 140 different dimensions for the length, the height, the width of these lamellas, and so on. And you've just to type in different figures and then wait maybe 3 minutes until the new geometry is generated, and then you have the new one. And this is very, very versatile as a type of, let's say, template, other than in the textbooks for process engineering, how it used to be. We don't have anymore the recipe how to design this with pen and paper, but this is there as a digital model, and you can just apply this to a different chemical question and then generate the right model, which is perfectly appropriate. I think this is the first shot, of course, but there is much mindset behind how this can be used, and then the fine-tuning can be done with the thermal simulation and with the flow simulation, so that you have really the optimum design for the purpose you need. And yeah, when it's finished, you have just to manufacture it, and this means you go then again through a digital manufacturing process. From CAD, from the print preparation, it goes then into this lasering of these structures, layer by layer. If the remaining powder outside is removed, you can take the object out of the bit plate and go into post-processing, clean it, and then you have it ready. And this is where we currently are. So it's pressure tested for 300 bar, water pressure approved. It's tied for 50 bar hydrogen over 70 hours. And it's operated now in the KIT labs, which are partner in this project, to completely analyze this. And this will, I think, probably go on for further half a year. And we were very proud that this also convinced the community outside. So I mentioned already last week there was the Formnext fair, and there were 6 awards announced, also one for design, and we really won the Formnext Design Award, and here it is.
Yeah.
And Roland can also ask Peter, he has seen everything.
Yeah, and this is from the customers, yeah? I mean, the industry
representatives
give this prize, yeah? That's cool.
Okay. It's not a Siemens award, it's from the international fair, yeah?
Yeah.
So I also highly like Siemens awards as well, but this
okay. But Christoph, the clock here tells me our time, unfortunately, is coming to an end. So let's conclude a little bit. We started with the challenge of getting circular in process industry and thought about how is nature doing it, on the one hand by closing the carbon circle, and on the other hand by having highly integrated devices, highly integrated functional devices. And with this we could save energy and resources. What did we achieve?
Yeah, I think the current achievement is that we can digitally design and digitally manufacture tailor-made equipment coming from a template which is very generic. And this can be then additionally done in a super alloy material with multi-hierarchic structures. So this comes really very close to kind of bionic functionality. And I think from a business point of view, so wherever you have remote locations where you need a not refinery-sized amount of product, but maybe a certain amount of product, this might be used. And unfortunately, we are now discussing also some security topics in future, and it might be that this also influences this business. Yeah, and then where do you see the opportunities?
Yeah, beside that, this is a really cool technology which gives that benefit. I think the opportunity is really in bridging from the digital world to the real world. So having, on the one hand, highly advanced digital twins, which cover physics but also chemistry in high accuracy, and having then the technology like 3D printing to materialize the devices that were designed very specialized for this problem. And as somebody who works on highly accurate digital twins, but also on experimental testing under technically relevant conditions. Yeah? What is a really good opportunity and a unique selling point is if you have a one company solution where from the design over the production to the final customer or applicant, you have a software platform which covers and connects very well to this. So here I think I'm really happy to what we can probably do in the future, that we can develop there new development chains and new products.
Yeah. Thanks for your attention.
So before you leave, I have a question. How heavy is this? Can I hold it?
Of course. I can take your microphone. So you can report.
Yeah, okay. This is heavy. This is heavier than expected, but I was doing weightlifting so far, so possible.
So it's 7.6 kilogram.
This plastic.
This is light, but fragile.
Okay, easier. Okay, sorry. I was just too curious. So thank you guys. We're going to continue with our next keynote, and that will be about harnessing technology for a sustainable battery life cycle from Professor Susanne, Lehner and Dominik Budday. Please come up to the stage. Just a few words still. Susanne is the chair of electrical power engineering at FAU. She's an expert in electrochemical energy storage and management, especially when it comes to hybrids and battery systems. And Dominik is product owner at Siemens Battery Solutions and another successful alumnus of FAU. So a lot of cool people came out of there. And he's not only an enthusiast for innovation and robotics, but also about creating a positive and sustainable impact, according to LinkedIn at least.
Thank you for the check on my LinkedIn profile.
Yeah, we would like to welcome you to our presentation as well, and would like to guide you through reusing and of course also recycling of batteries on having circularity in the full scale.
Yes, and I think we already heard quite a bit this morning about this topic. And for our side, of course, looking at it from an industry perspective, we like to start with the market. Yeah, and despite a lot of short-term headwinds, especially here in Germany and in Europe, we do see, of course, an ongoing significant growth for this market of battery recycling, and it's driven, of course, by multiple factors. The first one here in the middle is, of course, the rapid increase of battery electric vehicles. If you take a look at the global perspective, then this is still on the rise, and always every year I think it was higher increasing than predicted before. A second topic that we already heard quite a bit about is, of course, resource scarcity. Yeah, as an example, lithium here, where the capacity is really expected to be exceeded by the demand. And the third one, and that's actually a good sign, is of course also policies and regulations. As one example, of course, the battery regulation here in the EU that prescribes recycling targets, so really quota on how much material from batteries needs to be recycled, and also recyclate quota, so a certain percentage of recycled material that needs to be used when building new batteries. And all in all, that means that we're looking at a growing market which is going to reach maybe more than 20 billion by 2030. But it's a global situation and yet regionally distributed.
Yes, and that we would like to take a closer look now, because currently there's a lot of discussion on actually are EV sales down or how is it working for the automotive industry. However, if you take a look in the global picture, we shouldn't look too much with our regional scope on it. If you look, for example, on the market, given here, you see the US, Europe, and China, and where actually the main amount of lithium-ion batteries is required within the next years, and that's the current figure already with 800 gigawatt hours in China, whereas US is more in the range of 250 gigawatt hours. So it's tremendously less, and therefore we really have to take the global picture into account in order to see how actually the speed is increasing. And if you take a look at the last years and also the predictions, we still see a global growth rate of annually 27%, which is quite a lot. And at the same time, on focusing on regional pictures, also the resilience of our supply strategy, of course, especially with batteries, is quite a crucial factor. And on the right hand side, I depicted you the two most important cathode materials which are used, which is namely LFP and NMC. And what you can see, the vast majority of it, especially when it comes to LFP, is only produced in China. And therefore we have really a huge dependency here in our supply strategy. And that's something which is, especially when it comes to our automotive industry, that's really a critical factor at that point in time. And therefore, circularity becomes more and more important, and that we want to take a look at now a bit more in detail.
Yes, and we already saw pictures of circular economies and how they look like. So here is one for the battery industry. And as you heard before, right, of course, we start upstream somewhere with raw material extraction, components and material production. Then in the case of batteries, of course, you have these different layers. You produce cells, then you integrate them into modules, and then finally in packs, until you really reach your final product that is ready for its first life, its first usage. And this is where typically the forward logistics end. Yeah, you would dispose this product afterwards. And now, of course, when you close the circle, then you have the downstream steps, starting with transports and logistics. Of course, you need to collect those old batteries. At some point, then you need to disassemble them, you need to test them and understand sort of, you know, what's their status here, discharge them, and then eventually treat them in chemical processes like pyrometallurgy or hydrometallurgy to really extract those valuable, especially cathode materials, and bring them back into the circle. Now, of course, this is the picture that we would like to see, but it's not the reality yet. There's a lot of gaps still when you consider the circular part of this. You know, not all batteries get collected. You can't really disassemble them really efficiently. So there's a lot of, waste in these processes. Then the chemical process steps, of course, take also a lot of energy and so on. So there's quite a lot to do. And the second aspect is, of course, this circle is quite the long way. We heard it before, right? From an ecological point of view, and also hopefully from an economic point of view, it makes sense here to take some shortcuts, I would say, yeah, and trying to repair those products and extend the lifetime, the first life, also refurbish, remanufacture them and so on, and try to bring them into a second life before you go all this way to recycling. And so what are strategies here maybe that we can do when we want to try and shorten these life cycles here?
Yeah, exactly. So first of all, when we think about a material which is quite scarce, we have to think about how can we optimize its lifetime? How can we optimize the usage by utilizing it in the designed environment as long as possible? We're talking a lot about second life. However, first of all, we want to utilize it in the best possible manner in its actual application. Therefore, it's important for us to understand how are the cells actually behaving. So we need to characterize them wisely. We need to see what does a certain type of cycling of the batteries, of the usage profile actually do to the cells. How can we optimize it during operation, like changing the state of charge it's usually kept at, or the depth of discharge, using it in a different range. So those are all quite fine parameters, and they have a lot of interdependencies to different ones. And also, and that's a first cycle we see in here, is it has an impact on the materials which are used within the cells and how those materials are structured. And therefore, this feedback from the actual applications and how the systems are utilized is very important for the material development. And I've brought here as an example 2 figures of namely the same material of 2 large cell manufacturers. And as you can directly see, without being a battery expert, they no way look the same. So in the way you structure it, how you apply it, and also how you formate your cell at the beginning, that has a huge impact, and it can be directly related to what we learn from the testing, from the usage of the batteries itself. And the best utilization I already mentioned, so having different cycle depth, different state of charge levels it's operated in, you can really change your system. You can see, does it make sense maybe during the usage process of the battery to actually change the way it's operated, like shifting certain parameters and by that further utilizing the material that is used. However, at a certain point in time, we will have to decide on, do we go for a second life application, or is it still too good to go, actually? So in that, first of all, again, it becomes important for us to identify actual outliers at an early point in time. On the left-hand side, I depicted a bunch of cells, which are all from the same batch. However, what you can see, you have quite good or quite bad cells in terms of aging. Therefore, it's important to predict already at an early point in time whether you're in the upper dark blue line or in the lower dark blue line, because of course that will do a lot of change on how you utilize it in the first part, but also whether it still makes sense actually to bring it to a second life application. And that you can also see by the second point I depicted here. I did 2 dashed lines, and basically what you see, you have quite a spread in between, and it goes quite flat in the beginning with the aging. However, at some point in time, we see quite a knee in here. And of course, it's important whether your cell, once you reach the first dashed line and you want to use it in a second life application, whether it basically dies right after, and then a restructuring of the system, of course, is not usable anymore, and you put more energy basically in producing the refurbished system as you can utilize it later on, or whether your cell will go on in a quite flat shape for a while and you ideally reach a later point in time. So that's something you need to utilize. You have to understand what's happening in your systems, and you have to transfer it basically to the systems which are in the market. And then if you have systems in the market, you can have different effects you encounter where you have certain differences, for example, in voltages or things like that. And in that case, it's of high importance to identify whether this divergent behavior already is an indication for processed aging, or whether it's, for example, something which can just be balanced within the system and it's still good to be operated in a further way. And to distinguish that, it's important to detect certain usage patterns within the systems. So also here, the digital twins we already discussed a lot about today play a really significant role, especially as those systems consist of a vast amount of individual cells, so you won't be able to track every parameter on the long term in a detailed manner. And that brings the digital twins to a very important point. However, at some point in time, we have to bring it to recycling. And that we will focus on now.
Exactly, and as you heard, it's a lot about the capacity and the energy also that is stored in these batteries. So when they come back from their life and reach their end, at some point they also need to be treated safely, and this is one crucial step here. It's really about discharging them. Yeah? You are treating with high voltage battery systems. And here at Siemens, we have also developed a first deep discharge, so it allows you to discharge the modules of these batteries in an array or as an entire pack. There was actually some heavy lifting going on yesterday, so we had the first sort of bigger pilot setup for our customers delivered yesterday evening to Erlangen, and it's quite the cupboard. Yeah, I'm talking a big system when you do this at industrial scale, of course. Yeah, and besides the purely sort of deep discharging, of course, of these systems, there's a lot more that you can then eventually add on top, via added value. And we heard exactly what Susanne mentioned, right? The first step is, of course, digitalization. With bringing data transparency into this picture, you can also treat those batteries in a more individualized manner, both during production and in the first life, but also when you then really discharge them to just make sure it's safe and we don't have a fire going on. Of course, artificial intelligence to generate those insights at what kind of status these batteries are, do that fast and at scale. And the third one, of course, is about automation, because we're always talking about hazardous systems. So automation here also brings the chance to not only increase speed and maybe the adaptability here, but also safety, of course. Now, besides discharging, another major step that we already talked about is disassembly. And if you put yourself in the shoes of a recycler and think about automating disassembly, then the challenge is not to automate the disassembly of one battery. Yeah, you just need to do that. But the challenge is recyclers get hundreds of different battery models, and they need to recycle and disassemble all of them on one machinery setup because they can't buy 100. Yeah, so automate disassembly of any type of battery model, and that's the question: how do you actually do this? And at Siemens, of course, we tried then to bring this into the digital world. Yeah, use data and digital twins and solve the problem there, and that's what we here did. So we use a battery model manager that is sort of a UI that allows the user to work with raw data that you can sort of generate via 3D cameras, for example, to build up a very simplified digital twin of those batteries. And that's something that needs to happen because right now the recyclers don't have any data. It's unfortunate because obviously the data exists somewhere. Yeah, the Mercedes knows exactly what kind of batteries they're building, as an example. The recyclers not necessarily know that. But then, in the end, you have a digital twin of the battery, in this case a geometric representation, and also a digital twin of the machinery, of course. And when you now bring them together, you can actually use quite advanced tools like vision-guided robot motion planning systems that really can automate the generation of these disassembly procedures in a quite nice way. And here's a video where you can see this. On the left, you see the digital twin of the cell and the battery. And on the right, you see the machine moving. There's a motion planner that drives this robot to a next spot where the camera detects exactly where the screw is now in detail positioned, and then the planner takes the robot to the screw. There's not a single motion on this robot that was manually programmed. Now, the next step is, again, there's another screw, yeah, the planner moves the robot all the way to the next screw. The camera detects sort of the fine-tuning, where does it need to go. You can see these blue spots, those were the data that we previously sort of recorded, yeah, and the green one is, where is this exact screw now positioned, yeah. Obviously, you generate this digital twin on one instance of a battery model, but you then hopefully disassemble multiple ones of them, right? And you have tolerances in manufacturing, you have tolerances in how these packs are positioned, so there's always some reaction that you need to be able to take care of. Yeah, in this way, we really believe that we can bring down the engineering efforts here in trying to automate these disassembly processes. Now, we started with, of course, unscrewing. There's a lot of other steps that you need to do, so I'm not claiming that we solved this problem already, but we're definitely taking the strides here. And as you can also see, it's still quite challenging, right? We said the data is available somewhere, but it's not really there where it can actually be used then. So what can we do about this? And that's actually the topic for the battery passport. And luckily now there is a battery regulation that sort of prescribes that starting 2027, batteries with more than 2 kilowatt hours need to have a battery passport when they come into the market. And the OEM, or the sort of the economic operator, needs to provide that. So I'm not going to go about all the details, but just for you to know, there's 107 data attributes contained in this passport. And it's not just static data, it's also data that needs to be collected during the life. Yeah, it's dynamic data. And that allows you then in the end, of course, also to optimize the recycling procedures, understand where they are at some point. And at Siemens, we're providing the IT infrastructure for a battery passport. I think, Roland, you announced it also yourself about 1 year ago at COP in Dubai. But we don't necessarily directly have the data in there. So maybe coming back to research, how do you create or get access to the data that needs to be in this passport?
Yeah, and that brings again a lot of modeling efforts, a lot of simulation efforts into place. So the first is we want to have a detailed model of the battery. The manufacturers, as you said, will have it. However, they are quite strict with regard to providing the data, and especially when it comes to the sorting processes, which are still usable, which do we want to recycle directly. We need the data of the system in the current state and not in the state the manufacturer provided it. So what we're taking a look at is performance measurement routines, where you do certain excitation efforts, and you distinguish between the different parts, and by that can draw also feedback loops basically on how the systems have aged, how they perform, what's changed. So that's one of the parts. The other parts, and that's something closely related to what I've spoken beforehand, is you need methods to understand at an early point in time how will my systems degrade, how can I actually predict aging. And the problem is usually we have a development cycle of new battery systems and new cells of only a few years. However, we want to use it in the field, depending on the application, between maybe 8 years roundabout, up to 20 years if it goes for stationary systems and things like that. So we absolutely don't have the chance to test for a very, very long while on these cells, because actually we already go for the next technologies and for the next level within the time of testing. So making quicker processes and understanding these factors and adding it to the passport is one of the points. And then as mentioned, not only preliminary data or the data at manufacturing shall be used, but also life cycle data shall be collected. So training by field data, continuous state adaptation, doing the algorithms for that, detecting those points where you can actually adapt the things stored. That's something we can add by research and provide to those more than 100 data points that are available in the battery passport in the future. And yeah, with that, I would like to hand back to you for our summary.
And yeah, I think that's also already bringing us to the summary and an outlook. So I hope we could show you a little bit at what stages we can use technologies and innovations to really drive forward the challenges or solve the challenges that we're faced with in the topic of battery reusing and recycling. There's, of course, a lot of news going on, right? And one of the central ones, of course, also being here in the middle, the struggles that we see at Northvolt and also VW as just a representative symbol that we see right now, especially in the German market here. But we do want to highlight that there are short-term headwinds. We need to get through them. At a global scale, the battery market and the battery recycling market, they will come. Yeah? They're regionally distributed. They're developing fast. They're still early stage when it comes to recycling, but they are continuing to rise. And for the perspective of Europe, yeah, I think we can say that it will only be successful when circular. We need to get those resources and keep them here. It's often, sometimes still dealing with production issues, but it's also still a hot and broad topic. Yeah? And just to give you 2 examples, there's, for example, one here where EnBW provided or is operating now first second life battery storage system. On the other hand, we just recently heard in the news also Mercedes, yeah, operating their own recycling factory, and I think very fresh from the news also BMW has a direct recycling plant near Garching here. So there's a lot of things going on, and there's a lot of technology and innovation needed to address those challenges, and I think we have the right ecosystem here when I look into the room. So also for the young talents here, I think it's a very good choice to go into this market. Yep. With that, I would say we thank you very much for the attention. If there's questions or you want to get in touch afterwards, please do so.
Thanks a lot.
Thank you.
Thank you as well. All right, with that, I would directly hand over to our next speakers in case we don't have any questions. Just checking, okay. All right, and the next speaker on stage will be Ruben Fritzsch together with Negar Ghahremani, I hope I'm pronouncing this right, from his team. And Ruben is Head of Supply Chain Logistics Europe. He has been working in supply chain roles for the past 20 years and a passionate leader with automotive and industrial background. And in their keynote, they're going to talk about resilience in value creation systems. Can't wait to hear it.
Thank you. Thank you very much. Yeah, really enjoyed, and I'm still flashed by the contribution we just heard about methanol and about BEVs. This is a perfect segue to logistics, I would say. And right before the lunch break, I would like to invite you on a small journey in the area of logistic and supply chain management. And I would like to start with a short movie. And please do me the favor, take on the role of the customer receiving the consignees you will see. We are not doing it for an hour. I think I achieved what I want to do. Not only that you make you smiling, this is also nice, but I think you got my story. And the scratch is here. Maybe some of you counted how often we knock on the door of you as a customer. It was 9 times. Why do we have 15 scratches? I will answer that question very soon. But the most important thing for me working in logistics is this final impression we have at the customer door. This is the very last mile of our shipments on the way to the customers. Is our customer finally pleased to hear from Siemens? Or is it a little bit like in your case that it's just disturbing your business? And of course, this is, by the way, a picture I did here because we did not found a proper picture. So don't worry, we can use it in the internet. And finally, and this is the important thing, we want to make this supply chain a little bit better by solving this problem. My name is Ruben Fritzsch. I'm responsible as Head of Supply Chain and Logistics Europe in Smart Infrastructure. What have we done to make the life of our customers a bit better? First of all, and this is really important, a supply chain, and this is what we learned during COVID, needs to be resilient and, of course, sustainable. This is the minimum design principle I would say we have for any transportation and supply chain network nowadays. How do we do that? Coming from the customer first, we go to anticipate the customer expectation. And in our case, you have seen that. How about service times? How about packaging? How about the physical condition of the shipments? How about the reliability? How about digitalization and automation? This is what we are going for. We have a huge systematic, a digital twin approach, as we heard before, to calculate the data. So it's quite easy to detect patterns. We are still working on AI-driven systematics to support this. Today it's based, of course, on Snowflake, on SAP, Celonis, you name it. However, it brings us into the situation to really find patterns and improve the supply chain. It's about fostering collaborations. And why is collaboration so important? As Siemens, we do not have a huge fleet. I would say 98% of our fleet is external, so we buy it as a service. Logistics is a service. And when it comes to an external service, you have partners you need to rely on. You have partners to invest. And of course, we are here today with FAU. Even FAU is a partner, a very valuable partner for us to support this modern concept, state-of-the-art solutions to drive the supply chain of the future. We just talked a little bit about the digital twin, about data, mass data. I picked one example for today, and this is our supply chain to the Nordics. We have an impressive 4,000 customers. We have a little more than 3,500 tons of material being shipped every year. It will be 150,000 shipments, 160,000 of those parcels here, you see them. Yeah. I will come to that later. This is the typical size we are shipping. And it makes in total roughly 140 million euros of turnover for this specific project. And the movie, as funny as it was, is really, I would say, reason enough for us to improve the supply chain. Because what you can see here on the screen now makes our problem, I would say, obvious. The only top 3 customers, let it be you in our movie, are receiving 15% of the shipments, which is not a problem. We are happy for that. But of course, receiving 14 and plus 14 packages per day from entire Siemens. Because this is also important in logistics, I think this is, we are Siemens. We are one Siemens. We are not SIDI. We are contributed as Siemens. And this is what I did here. We have counted the overall number for that particular market. And you see the top 15% of the customers having 72% of the shipments, and so 72% of the overall potential for our optimization approach. So what did we do? We developed together with a forwarder a concept to collect all the shipments in Germany, all the shipments in the area of Nuremberg. Why is that so? Because here we have the huge distribution centers. We have Bohr, we have LZA, we have Nuremberg. And as a consolidation point, geographical, this is the perfect point. And what you see here is exactly what I have here next to me. This is, I would say, the shoe boxes we have every day, same customer, same shipping locations. We get them sorted, which is not, I would say, the challenge. The challenge is, you see it here in the consolidation, we create new shipments, get it labeled by our forwarder, create an EDI to the next level forwarders, and consider it now as one shipment. So this one shipment goes to our customer, as you see here on the last mile, and of course reduces heavily the packaging and unpackaging and identification effort in the last mile. And it of course reduces the number of transports you saw in the movie significantly. In an ideal case, 1 Siemens overall delivery per day to one customer. Here's a little bit, I would say, stuff to see the financial, the monetary potential of it. We created together with that customer a degressive tariff function. And in this tariff function, you see easily, as more shipments I have, as less we as Siemens pay in the transport cost side per kilogram / per parcel. So this handles in a perfect way, in a resilient way, in a sustainable way, the overall number of shipments, while saving even a little bit more on the tariff side. So the overall impact of the program, which is totally scalable, and I would definitely invite all of you being active in the supply chain area to contact me and to learn about it. I'm ready to share the content, I'm ready to share the concept and the structures. The overall impact on the soft, I would say, fact side is of course the collaboration piece, because we developed an ideation and co-creation logic with our forwarders. We have a trustful partnership and investing on that side. We also, of course, increased the positive customer experience. And there is first positive feedback. We got in our Net Promoter Score annual ratings from the customer side, so we definitely want to scale it. We definitely want to roll it out. And on the hard fact side, you can say for the sustainability piece, together with our requirement for this forwarder to really use HVO 100, we make less than 60% reduction in CO2 emissions. And of course, not only based on HVO, but also based on the reduction of the miles driven. Coming to the competitive advantage, of course, this concept saves money. So overall, minimum, if only SI and if only the business we considered, it's 15%. If all Siemens units for the same market, same customer would go on board, it's 30% cost reduction potential for us. So this is, for me, definitely a contribution to the overall resilience, because we are not depending on a fixed concept. We are very flexible, and we can handle the market in a very positive way. Last but not least, I would like to hand over, because of course we are working with FAU intensively, and I would like to have Negar to say a little bit about the collaboration with FAU.
Thank you, Ruben. Hello, everyone. My name is Negar. I'm a working student in Team of Hub of Europe, and also a master's student at FAU studying industrial engineering. And now I want to explain a little about the collaboration between these two organizations. SI Logistics does collaboration with 3 different departments from FAU. First, we have supply chain management. They have various programs like reverse monitoring, strategic, and insight and research. They have various industrial and research programs. But more specific on sustainability, they have a joint project with business administration department. And from the upcoming calendar year, they have a joint project again focused on resilience, and it's called ResiCamp. And more about my own experience with supply chain management department and SI logistics, about reverse mentoring, which I participated in. I think it's a very valuable chance for students. They can share their ideas and also get to know the experts from the SI logistics. And also, I think overall the collaboration between FAU and Siemens is a triple win for students to gain hands-on experience, and also for Siemens and FAU to be updated through the research programs. And that's all from my side, Ruben.
Thank you very much.
Thank you to the both of you. I love that everyone is bringing something to the stage. I hope we continue with this. But for now, we're going to have a break, and that's also your chance to talk to the speakers, get your questions in, and yeah, so get a snack. We're going to continue at 12:15, and yeah, see you in a bit. All right, so everyone, I'm so happy to see that everyone is networking here like a maniac. Nevertheless, we need the room and also a little bit of silence to give our next speaker the attention that she deserves. Now our conference is focusing more into the area of collaboration and also the importance of ecosystems. For the next Impulse session, we have no one less than Cathrin Tenbrinck. She's Program Manager for Sustainability at Siemens and Cluster Lead for Circularity for the Siemens Core Technologies. What I particularly love about it is that she's not only a true techie and has a diploma in pure mathematics, I mean, props for that, but she's also an advocate for female empowerment. So I'm happy to have another female here on stage. I can't wait to hear your perspective on how to drive circularity through collaboration, collaborative innovation. And with that, please, round of applause for you.
Yeah, hello. Welcome. My name is Cathrin, and I like to talk about how we can actually implement circularity. So we already heard a lot about what is needed to become circular, what technologies can be applied to improve in regards to a circular economy. And now I like to focus on how to actually bring this into action. And to start with, I like to give a little definition of a circular economy, and here I refer to the Ellen MacArthur Foundation, who says a circular economy is a system where materials never become waste and nature is regenerated. So, and if we want that materials never become waste, then it seems to be a good idea to start with recycling, right? And recycling is also something which is quite familiar to us, as we know it from the waste treatment at our households. And it also seems to be a good idea because only 13% of global waste is recycled at the moment. So yeah, why not recycle everything? And here comes the however. In most cases, recycling turns out to be downcycling. And this is because our products are not designed to be recycled into degradable material fractions. And yeah, therefore, if the design is the issue, then yeah, why not go to the design departments and start our circularity journey in the design phase? And yeah, so let's design our products. We already heard it, with sustainable materials, biodegradable materials, mono materials, and also design our products in a modular fashion such that they can be decomposed into parts that can be reused. So designed to extend the lifetime and make them easy to repair, reuse, and remanufacture. But also here comes a but, because have you ever asked an engineer to completely change the processing pipeline just because some designers had that brilliant idea of decarbonization and ensuring resource efficiency? You cannot just simply throw away the complete factory inventory just to adapt to this new design of the products. So then the question remains, how to implement closed-loop systems? And now I'd like to take one step back and let's have a look at how a linear value chain look like. So we start with the design department, then we have the engineering who is taking care that we come from a blueprint to something that can actually be built. We have procurement taking care of the supply, and then we have production and manufacturing, and we have logistics taking care that our products come to our customers. Now, how does it look like in a circular approach? So, and you already can see, we gain a lot more process steps. And this is not all. Also, the focus is shifting from the production side to the use phase. Because the principle of a circular economy is to keep products in use as long as possible and to circle them at the highest possible value. And this means that the most important loop for us is here the first one, the product loop. And only if the product cannot be reused or repaired, then we do disassembly to gain the product components, which can still be reused. So, and here we are talking about remanufacturing. And only the last resort should be the recycling. And also here, we are taking care that the recycled material is going back into the production. And we already heard about these 3 loops, and I like to introduce a 4th loop here, which is, with a dotted line, the knowledge loop, because we are not yet in a circular economy. There is still a lot to discover, a lot to learn, and all these learnings and experiences need to come back to the design department to further integrate it, to further improve and optimize the design of our products to enable circularity. Okay, and now let's come back to our initial question. You can see we have a lot more process steps here in a circular approach. And with all these process steps, you have a lot of dependencies and interconnectedness. And we at Siemens thought it might be a good idea to gather all the experts, domain experts of the various fields and area of responsibility they are working in, and who are at the same time circularity enthusiasts who want to change from linear to circular and drive the topic forward. Together, these people together in one community to foster exchange, to inspire each other, and to jointly drive the topic forward. And How are we doing it? We meet once a month, and our meetings are split into two parts. First, we start with an inspiration or a keynote, and then we have the second part, which is really this interactive part, the collaboration, where we send the different people into different breakout session where they have to work on different use cases, or sometimes we have circularity challenge of the month, then they have a task to work on. So we really foster this collaboration, as we see this as the essential part to drive and then with this implement circularity. And the loop picture I was showing before with the 4 circles, this, for example, is not invented by the circularity community, but this explicit visualization is something we developed within the community. And as you might have saw, there is no waste in our visualization, because we designed the future perspective, the status where we want to be in future. And this is an innovation method which is called future-back thinking, and which perfectly supports the transition into circularity. Okay, so we already have this community, and we are collaborating across all departments within Siemens. But even if Siemens is a large company and a global player, Siemens cannot do the transition into circularity alone. And this is because Siemens is part of an even bigger ecosystem. And we not only need to collaborate internally, but in this whole ecosystem. And we already heard about the importance of ecosystem and the collaboration between different parties, like, for example, research institutes and universities, here represented by the FAU. And we need that they develop new ideas, new technologies that drive circularity. We also need to collaborate with logistic companies. I was mentioning that the logistic is taking care to bring the products from our factories to the customer. But why not in future taking the empty truck, taking all the used products from the customers and bringing them back to our factories, and then repair or remanufacture the products there in the same factories? Could be an approach. So, and to really talk about that kind of solution, you need ecosystems. And now let's have a look at an example. And as the world is transitioning from fossil fuel to electrification, the demand for energy surges, for battery surges. And that this transition from fossil fuel to electrification is a sustainable transition. The EU is requesting the battery passport for every industrial battery from 2027 onwards. And for this reason, Siemens is a part of various associations, consortia, and also industrial networks, so business sector networks like here Catena X for the automotive industry, to really get the holistic picture on the topic. And yeah, and we are not part of these networks just for the sake of it, just because we like to network. No, there is a business case behind it, and this was presented some minutes ago. We have this Siemens battery passport, which is a data ecosystem to support all involved stakeholders along the whole battery life cycle to access the data and also manage the data. Now, coming back to our ecosystem, there are a lot more important stakeholders within an ecosystem. And here I like to make the connect with this wonderful, inspiring location here, because tech incubators like ZOLLHOF are also very important as they foster the entrepreneurial spirit, and they are bridging the gap between companies on the one side and the startup landscape. And the ZOLLHOF is a perfect location for collaboration. And okay, and now I'm talking about startups. What is the importance of startups? We already heard a lot about that we are not yet in a circular economy, and there's still a lot to learn, to discover, to try out. And startups are known to be creative. They follow an agile approach. They are fast. They are willing to take risk. So they are the ideal catalysts to pilot circular solutions and also try out different business models to find the sweet spots. And it is not one-directional. Also, the startups can benefit from the collaboration with companies like, for example, Siemens, as we can offer the industry perspective, market access, and also scalability, because this is, we already heard it, also very important that we find solutions that can be scaled. So what did we touch upon? Design is crucial if you want to implement circularity. Then it is important that we look at the system, at the topic from a system perspective, to really have the holistic picture and not developing solutions that don't fit to the whole system. Continuous exchange and collaboration are key. We need to collaborate wherever possible to find solutions that are sustainable but also economical. Startups as catalysts, and we will hear more about startups later on, therefore I won't go in details here again. And there's still a lot to discover. There is still some kind of become the next funny workman, or if you're not so familiar with female discoverers, let's say the next Christopher Columbus. And therefore I like to encourage all of you, let's jointly drive this transformation. Let's make circularity a reality. Yeah, thank you.
Also, thank you, Cathrin, for touching.
And one second. And if you have any questions or want to know more about it, you are really welcome to join us downstairs in the marketplace. There is this CCT poster, and my colleagues and me are happy to answer all your questions there. Thank you.
I mean, I just want to say thank you for touching the topic around startups, because that's kind of what's happening here as well. And I do believe it's just important to look at them at eye level and to kind of see them as an equal partner. And that's what I love, that because it happened in the next session, kind of, in what they're going to talk about. In the next session, Mirjam Mantel, Matthias Gerlich, and Professor Andreas Maier will show how they implemented a full circular design for plastic packaging. And I really love how this is really bringing different parts of the ecosystem together, because we have Mirjam and Matthias from the industry side, we have Andreas bringing in research expertise, and additionally, there's also one of our own ZOLLHOF startups involved that is partnering with you, and I'm very excited what you're going to share with us about this project. Thank you.
So thank you, Cathrin, that you emphasized collaboration is key, and that This is why we will start a video, or talk with video, showing one of the colleagues, because it's people who are behind driving a topic and who are fostering collaboration, and this is why we asked Takeo where to click.
Maybe the other one?
Next.
There's
no, our clicker, okay.
There's two of them.
Good afternoon. I'm Takeru Nemoto, an engineer working at Siemens Foundational Technologies. 7 years ago, I joined Siemens as a PhD candidate in field of robotics, supervised by the University of Erlangen-Nuremberg. Since then, our research group has continued collaborating with the university, and today we want to introduce one of our ongoing projects. This project aims to tackle the plastic waste problem and involves partners from Siemens research and innovation ecosystem here in Erlangen-Nuremberg. Unfortunately, I could not be there today in person, but my colleagues and our project partners will introduce the project. Enjoy.
So we would like to introduce to you the AI hub, an application hub on plastic packaging and recycling. We will show you at least 2 projects with more than 50 partners from science, from industry and from society, working together on how digital technologies can help to solve one of the big challenges of our time. And this is the closing the loop of plastic packaging. My name is Mirjam Mantel. My colleague Matthias Gerlich, as was already mentioned, we are from Siemens Foundational Technologies, and now I ask you, Andreas, to explain what is the vision behind this project.
Yeah, so thank you very much for this very kind introduction. It's a great pleasure to be here and to show, actually, so this is part of a twofold funding procedure, the innovation hubs. There's one for product design and one for recycling, and I'm actually the PI of the recycling hub. So each of the hubs is funded with 13.5 million euro in order to bring the industry in recycling ahead. And of course, there is a huge endeavor. I may add, was introduced as professor from FAU, but I'm here actually in the role as project lead from Fraunhofer Integrated Circuits. So just to make that clear, otherwise if there's somebody from Fraunhofer in the audience or in the online audience, they say, oh, this is of course also FAU Siemens, but there's also Fraunhofer involved. So I hope the Fraunhofer colleagues are not upset now about me that I explicitly made this clear. All right. So what is the thing with recycling? And in particular, in our recycling project, we're interested in plastic packaging. And one of the problems is, we need this circular economy, and there is many links. You know, we have to do a systemic design. And the partners that are involved right now in each of the steps, they are not very transparent because they have their own company secrets on, how to do sorting appropriately, how to manufacture things very well, and they don't like to be fully transparent about everything as you would like to see. So there is a certain resistance in sharing all of the information because you also have to protect your IP and your trade secrets. What we want to do in the project is link across the company boundaries and therefore not just have companies optimize on a local scale, but also give them means to optimize towards a global goal, like CO2 reduction and also increasing the amount of material-based recycling, so that you really reuse the materials and not just, put them into energy production. So how do we want to do that? First of all, recycling industry is to some degree already digitized, but not as much as in other industries. So it's a very, very nice environment, to go crazy about digitization. So of course you think of digital twins. We've seen digital twins all this morning, and it's of course a very important technology, but we want to take that one step ahead. So we call this the artificial neural twin. So it's not just an digital twin, but it's connected to a machine learning approach to neural networks. And the nice thing, if you make your digital twin essentially compatible with neural networks, you can make them communicate across sector boundaries, company boundaries, and share information. So this is a key concept that actually I think made us win this project, because it is a tool for holistic optimization and analysis. And as a concrete outcome of the project, we want to have a new sorting facility that is highly optimized. in the way how the individual sorting steps and processing steps are done. And just improving on one sorting facility in Germany, we think that we can increase the material recycling by 8,000 tons per year, and that would be equivalent to 20,000 tons of CO2 equivalent reduction. If you scale that up to all over Germany, and that would be equivalent to a reduction of greenhouse gas emissions of 500,000 tons of CO2 equivalent. If you think about the air traffic, the CO2 emissions that are caused by planes traveling within Germany, so only within Germany. If you fly out of Germany, it's more. But only the plane traffic within Germany causes 300,000 tons of CO2 equivalent material. So we are in the same ballpark here per year. And how we're going to do that, key concept is this artificial neural twin, where you have the sorting facility. Here it's a near-infrared sorting machine, and of course you can create a digital twin that runs in parallel, but you can link it up to a neural network. And if you do that, it's very interesting, because then you can steer it with losses, and not just losses of local optimization, how to sort things, but also of further processing steps. So this allows us to move fast, but not break things, but to reuse things. So we can optimize along the entire process chain already in a linear processing chain. So of course we are compatible with the circle and connect to the other hub, but we can already optimize along the linear processing chain. And that's pretty cool, because with that we can make all of the sorting steps optimized towards one goal that can be, for example, CO2 reduction. So we are using here the technique of backpropagation. If you, I know some people here attended my deep learning class, so this is how you put backpropagation at scale. And with that, we already started, so I have some videos here of the initial sorting steps. So material comes into the facility, runs through different sorting steps. We have all of this, not just as a digital twin, but hooked up with a neural network that allows the different processing chains to actually communicate with each other. And I can tell you, these machines, they are, sorting by moving things around. There's a magnet that takes out all of the metallic materials. But if you optimize them, then you can, of course, increase the salvageable material, make the sorting better. But the key problem then comes at a later step. And this is where you typically have manual sorting. And of course, this is something that is very, very labor intensive. And therefore, I would like to hand over to my colleague first to continue on this journey. Oh, sorry.
Yeah, as you already mentioned, there are still manual steps in the recycling process. And as you can see in the video, this work is really physically and cognitively exhausting. The materials are deformed, they are damaged and of course dirty. And it's really important that the decisions are made very fast, and that you really need to decide. Also object recognition is very important. So this is why it is still manually, because humans can do better than machines for now. But there are some technical solutions already on the market, some first, but they are not as good as humans. Yeah, there's a need to improve the sorting quality of this system, and also to process more material like it is now done. We in the consortium, together with FAU Siemens and our partners, we see a potential usage of sensor-based robotic sorting systems. And yeah, I ask you, Matthias, to tell us more about it.
So we want to improve the quantity and quality of sorting with robots. When you think about this, you doing it, sorting this, you have seen the video, you need basically three things, and these three things are also needed by technical solutions. You need detection, you need recognition, and then you need some manipulation. So you as a human, what are you doing? You're detecting the objects coming on the conveyor with your eyes. So the eyes are your sensors, and you detect these objects. The detectors are providing information. It's the size, it's the color. So that's the detection part. We are doing this here with sensors, different sensors, also providing visual information, but also sometimes information already on the material. Second thing is you need to recognize it then. So yeah, you get information, but what is it then in the end? This is what you do. You learn it here. When you do these things, you learn it. Somebody is training you and saying, okay, this and this is that and that material, so pick it up. We do this here, of course, also. We use intelligence, but of course artificial intelligence. So we use the sensor informations. We need AI, which is trained with this sensor information, and then to be able to recognize these materials and the objects with artificial intelligence. The third one, you recognize your objects, then you need to manipulate them. You need to pick them. You as a human, you are doing this with your arms, with your hands. You heard it, it's very exhaustive. And you learned a lot when you've been a child, and doing these things is not that easy, but you learned it. Here we are doing it with robots, and robots, yeah, we know there are already robots learning things, being able to learn, but at the moment we are doing it with algorithms. Yeah, and we do this as introduced with different partners for these different work streams. We, with the FAU, we are doing here a work on robotic concepts for this sorting, and we're coming back to Takero. He went to this site and did this by his own to see what this sorting is. He told us he needs to stop after 30 minutes. It's very it was very intensive for him, this sorting stuff. I said, yeah, he needs to stop after 30 minutes. The people there are doing this 8 hours a day. So what we did, we transferred this scenario to a virtual environment. Budget is short, resources are short, we want to be fast, so we do this in a virtual environment. In this virtual environment, we have the conveyor belt, you will see the randomized waste stream, you see the robots picking the things. What you can't see within this virtual environment, we also have the connection to the sensors. We are simulating our automation devices, and the algorithms are running in this digital twin. So you can see, we can analyze, we can optimize this system here in this virtual world. And what we can do is we can compare different setups and scenarios. On the left-hand one, there's one robot, on the right-hand one, a different one. Comparing the things, optimizing the things to really get the best benefit. Enhancing really the quality and quantity of the sorting. And if you compare this here, for example, you see the numbers on the screens. The one in the front is doing better than the one behind. Even the other one has the higher reach, but the speed is not that good. And in this comparison, the one in the front would win this and really would enhance the sorting quality.
Thank you, Matthias. Thank you, Andreas, for giving us some insights into this innovation projects. As I already mentioned, there are much more partners. This is here for the key cyclings of one of two projects where Siemens is participating and learning a lot about this environment, this industry. And yeah, we thanks to these partners, we can really work on how digital technologies can help to close the loop of plastic packaging. Thank you. One last word from your side?
Yes, so one opportunity that I'd like to take is we are currently in the process, so one of the partners that is not listed here is actually DIN, so Deutsche Industrienorm, and we are about to start a process on standardizing this AI-ready interface and really create an industry standard. So if you think this technology is useful with some respect you're working on, please contact me directly, and maybe we would be interested in bringing together as many partners as possible for the standardization process. And one other thing I would like to do, as I see there's so many students that attend my machine learning, deep learning classes, I think right before lunch it would be really awesome if you could come up here at the end of the event and we take a group photo, because I'm so excited to see so many of you here. Thank you.
Thank you.
Thank you very much. Particularly love, whoopsie. Are you okay? I particularly liked also the videos that you brought in, seeing that the small robots or like the small players can also bring a lot of effort and actually more speed. And talking about speed, I would like to introduce you to the next two startups. We're going to hear now two pitches of startups who were also incubated directly here at ZOLLHOF. Both of the entrepreneurs are people who really thrive in this ecosystem, and that's also why this is so crucial that we're doing things like this here today. The first person I would like to welcome on stage is Matthias Trost. I don't know if you know, but he also studied at FAU, and he also did the talent program here at ZOLLHOF. So he's one of our, I don't know, people we are like very proud of. And today I would like for you to see what he accomplished with his startup Amperial, because there he's co-founder and CEO. So I'm happy to hear how you're going to make the world more sustainable.
Thank you very much. I'm just trying which clicker is the right one. Here we go. All right. So my name is Matthias, and my official job is the CEO of Amperial. But as well, part of my job is to make your life a little bit more comfortable and help Siemens as well to reach the decarbonization goals for 2030. I have to be honest with you. I think today is one of the shittiest time of the year to tell you that there's too much sunlight and too much heat when it's 0 degrees outside. But I'm not worried because the next summer is coming. So imagine yourself next summer, you're in your home or your office. I think it was the wrong clicker. Here we go. You're at the Siemens office. It's a really hot summer day and the sun is shining through the window. It's getting hotter and hotter. Yeah, for you personally, it's way too hot. You're stressed, you're unproductive, or you say, no, I'm gonna pull down the blinds, and then it's mainly too dark and you have to activate the electric lights even though the sun is shining outside. Or you're a lucky person and you have air conditioning. Let's be honest, super comfortable, but it's not the most sustainable solution, and as well not the cheapest solution out there. So here comes Amperial, and we are developing heat protection on demand. What does that mean? We're developing a building shell that is capable of reflecting the solar heat before it's even entering your building. The cool thing is you can switch that on and off whenever and however you like. With the benefits of, first of all, giving you heat protection on up to 7 degrees, but additionally as well, saving a lot of energy, up to 25% per building. And what we found out as well, it has to be easy to install. Nobody wants to do complicated measurements doing construction sites. It has to be convenient. So how do we do that? My co-founder Niall has invented a new nanomaterial, and this nanomaterial has pretty exotic capabilities to certain parts of the sunlight. In our case, to heat radiation. So we take this material and we print it onto transparent window foils. By applying a small voltage, we can switch the foil on and off. On the left-hand side, you see the foil activated, where it's reflecting mainly the heat component of the sunlight, whereas the daylight can still enter the building. On the right-hand side, the foil is deactivated, where it's fully transparent and fully transmissive, just like a normal window. That's not all. If it's not only too hot, but as well too bright, let's say late afternoon and the sun is a little bit lower, you can as well tint it on demand. So control the heat and the brightness and therefore your comfort. How does that look like? This is our smart window starter kit. So first of all, we have the smart foil, which we attach to the window, and it's combined with a small controller. And this controller is capable of activating and deactivating the foil, but as well communicating with the user interface. The cool thing is this controller does not need grid connection. It runs on battery and solar solely. For the user interface, we're pretty flexible. You can imagine everything from a digital solution to just a classical flick on the wall. As you can imagine, the main customer segments they're addressing is, first of all, commercial buildings. If you just have a look outside, it's so many windows, so much air conditioning, and large buildings. Of course, the residential area as well has a high interest, but there's mainly for improving the quality of life and gaining a little bit more comfort. And mid to long term, we're as well looking into the automotive and transport industries, because whenever there's glass and an air conditioning, we have a business case. I don't know if the air conditioners in the ICE are made from Siemens as well, but this could be as well a nice application if the train is getting too hot once more in summer. This is the last slide. This is how we deliver value. So basically we have 3 layers, highly focusing on B2B. And I think for you guys, the first one is the most relevant. It's about commercial buildings. The main benefits that we hear here is, first of all, of course, the improvement of the energy efficiency, but as well with sustainable technologies integrated in your building, you can as well increase the real estate value and therefore adapt to changing regulations, changing requirements. In the residential part, we're mainly looking to collaborate with partners because, as I said, there it's mainly the quality of life that people are interested in. And our scale case is the integration into new windows. So the first 2 layers are highly focusing on retrofitting existing buildings. Good news for you, we're already planning 2 pilot installations, 2 test installations with Siemens, one in Amberg and one in Erlangen, and those will start in the next summer. We're engaging with Siemens Real Estate and hopefully, deliver you in the next few years a couple of more cool summers. Thank you very much.
Thank you, Matthias. And with that, I'm going to hand over right next to Gianluca. He's the co-founder and CEO of Sypox, another of our cool ZOLLHOF startups. And they created the technology that enables chemistry without furnaces and fuel combustion. So please, can you explain that to me? What's actually that meaning? All right, and yeah, so I'm very curious how you want to electrify the chemical industry.
Super, thank you. Yeah, thanks a lot for having me here. And yes, exactly, I'm Gianluca, originally from Italy. I'm based in Munich, and approximately, let's say 3 years ago, we were part of the ZOLLHOF. And yeah, we are a startup affiliated with the Technical University of Munich, and we are working on electrifying high-temperature chemical processes. So I will start the presentation with a question. Let's say 2 of us want now to drink a tea and we need to have some hot water. And we can use, of course, these 2 different devices, right? And well, there is a main difference between the 2 except the technology. Would you guess which is the main difference between left and right? No? Also, if the left is closed? Well, the main difference is the energy source. On the left, we're using a fuel. So we are burning a fuel to heat up some water. And on the right, well, we can use electricity, right? So we need to use 2 different technology, but the 2 different technology have been developed to use 2 different sources of energy. Well, while this seems to be very trivial on traditional application that we are having at home, like an oven or like when we cook, this is not the case for the chemical industry. So the chemical industry, as you see, there is in this picture a lot of smoke, and mainly there is also some steam. Otherwise, Bastian will correct me because he knows very well what this is. But yeah, the chemical industry uses a huge amount of fossil fuel, which is fired in big oven, which supply the high temperature heat, which is necessary to convert a feedstock into a product. And we heard, for instance, methanol is also involving a high temperature step, which is let's say the conversion and the preparation of the feedstock for the methanol loop. And if we, of course, look at the hydrogen production, which you hear a lot recently, well, we have that within the existing hydrogen production plant we are having in the world, they are responsible for emitting approximately 3% of the world CO2 emission. And this is mainly because we are burning a fossil fuel to provide the high temperature heat. So what could we be doing? Of course, replacing the energy carrier, and rather than going for a fossil fuel, use electricity and then heating up the process using heat. Of course, to be able to do this, you need to have a technology, and we have developed such an equipment, which is not so easy because providing heat at 100, 200 degrees is very easy, but if you need to convert electricity into heat provided at 900 degrees is a challenge. And what have we been doing? We have been putting a heating element inside a pressure vessel, so inside a reactor, and in this way we are able to convert electricity, of course, if this is renewable, without emission, and also we are converting electricity into heat with an efficiency of approximately 95%. But at the same time, well, you come up with an equipment that is lower in capex, but also much simpler to operate, right? So a kettle to boil water is much simpler than taking a pot, put in the water, turn on a burner, and put the pot on this. Well, where this technology can be applied on different applications, and for instance, what we have already been delivering is units that are having an electrically heated equipment and which are able to convert biogas into hydrogen, while we are still scaling up the equipment to be able to address more centralized application, for instance, for the conversion of natural gas into hydrogen, or also the cracking of ammonia into renewable hydrogen. Well, we will have a bit more a look on this left side, and also because we are on a circularity conference, and you see what we are doing. So we can take biogas and electricity, and then we feed this into one of our containerized solution where we have our electrically heated equipment, and we are taking hydrogen out of this. Of course, there is also a CO2 emission, but let's say, well, if you look at the carbon balance, in particular, if there is a manure entering into the biogas plant, well, this is a circular. Actually, you can even go in CO2 negative. And yeah, with this is a picture of one of our units that we have deployed here in the region. Actually, it's near Eichstätt, and that is operating in a biogas plant, taking biogas and renewable electricity and converting into hydrogen. So yeah, with this I'm completed with my presentation, and well, another things that I guess I would like to add is we are hiring. If there is people interested, please contact us, and we just hired one person that was part of the talent group of the last session, right? And yeah, we'll be very happy to talk with you and see if there is a fit, and you will be able to help us on electrifying the chemical industry. Thank you.
Thank you. Right, you have the chance to talk to these two startups also later on in the marketplace. But before we get there, I would like to announce or bring in some news. And first one would be that the Siemens Professional Education, together with the FAU, implemented is the Sustainability MBA. And I would like to get Alexander Bach and Matthias Gerlich on stage to quickly share why this MBA is so special.
Thank you very much. Okay, hello everybody. I'm really happy to be here and can pitch the Master of Business Administration and Sustainability for the Siemens Professional Education in here. There are a lot of points I heard already that are elements of one of those master's degrees. Especially Roland Busch took the perfect pitch for me or for us. He mentioned in the buzzword bingo that his main sustainability hack was to do education and do studies. And for that reason, I don't think I'm convinced that education studies are the key to implement concepts into the society and into our economy. So for that reason, the Siemens Professional Education developed a program, a master's program with a focus on sustainability. It's a program to who it might be interesting. What is the target group? Everybody who might be interested in changing the economy, changing the society, or changing the business in direction of sustainability might be interested in this program. For sure, it's a master's program. For that reason, you at least need a bachelor's degree, but that are just the hard facts you need. What's so special about this master? This master is co-created from the Friedrich Alexander University, Siemens, and the Siemens business, Siemens Technology and the Siemens businesses. You might think, okay, what's so special about that? Usually the universities put up their curricula themselves, and here really an industry company, an industrial company and a university work together to put up this program. For that reason, it's really demand-driven. That's something that came from the industry where the company said, okay, we need this kind of know-how within our company, and that's something really special, and I'm convinced that's something really good. You can read some of the learning objectives. Everybody who is within a company might want to implement lots of things you heard today about sustainability into the company, into the business. And you can also see there are 9 elements, 9 modules. You heard a lot of them about a lot of topics of them today. For example, circularity, or about innovation, or marketing, project work, and so on. And they even did a connection within this program between our R&D department, so research and development, and the university. For example, if you see sustainability technologies, this is one module where employees from Siemens will do the topics and do the training for the students. I myself could talk for hours about this module or this master's program, but I think experience is way better than telling you bare hard facts. For that reason, I'm really happy Matthias is here, because Matthias was one of the first ones who did this kind of training. For that reason, he can talk about his experience with this program. Matthias, what was the impact of this kind of program on your personal life and on your business life? Where were the impacts, and what was your personal thinking about this program?
Thank you very much. First of all, am I audible? No, not really.
Technical issues.
So, first of all, many congratulations to the organizers here. Where's Constanze? No. You learned this in the morning from Markus Beckmann, who, by the way, is one of our brilliant professors in this program. You learned about R strategies, and that reusing is one of the most valuable R strategies. So reusing speakers here is very sustainable and very circular. So congratulations to this. So coming back to your question, what is it for me personally and for my business life? So first, for me, it's a great opportunity within this program really to develop myself, to learn new things, and really to gain skills in the surrounding of sustainability. Next step is, how does it influence my daily life, my business life? So I'm within corporate research and pre-development. And you could ask, okay, why should you do an MBA there? How is this connected? So first thing is, when you have a look at RPD, at research and pre-development, we are always faced to new challenges, to new trends, new requirements we need to fulfill. And sometimes we need to respond on this also by developing ourselves and learning new skills, we at the developer. Developing ourselves, not only our products. Yeah, why an MBA then for this? You know, we are scientists, we are technicians, and we are normally working on functional requirements, technical requirements. But you learned also this morning that circularity is a little bit different. Circularity is at first it is a model, and in this model we have different business models, and all of this is embedded in ecosystems. And if you really want to find creative solutions, technical solutions for circularity, then it's sometimes really important that you also understand the interactions and the dependencies between products, business models, and ecosystems. And yeah, not all of the developers need to know this, but I think it's important to have at least some of them. And I decided, and I hope I will be one of them. Yes, that's it. And when I have a look at my daily work within power electronics, I have 3 circularity projects, and with them I several times already used what I learned in this MBA program, and it was very beneficial, so in the end it pays off.
Thank you very much. Now, if you get curious about the program, after the event in here, down at the marketplace, we also have one of our a little trade fair. You can come up to us and talk to us, at least to me and a colleague. I don't know if you will be there. Then feel free to ask us about the program or other dual study programs from the Siemens Professional Education. Thank you very much.
By the way, I absolutely recommend doing a master's also in parallel to work. So I did it also myself, and I think it's an amazing opportunity to kind of put everything that you learn already directly into practice. So just, yeah, I don't know what to say that. So the next person on stage is Professor Tilman Bosch, and he will share how you can do a PhD at Technische Hochschule Nürnberg.
Thank you very much for the nice introduction. Thank you very much for the possibility of talking here. Before I start, I was asked to tell you something about how is it possible to earn a doctorate from the OHM? How is it possible to earn a doctorate from kind of our university by a University of Applied Sciences, from a Hochschule für angewandte Wissenschaften? Let me start before beginning with two statements. First of all, I think about when you organize a sports event, or when you organize maybe also a conference. When you organize a sports event, you also always try to have the best athlete at the end. When you try to organize a conference, maybe you try to have the best presentation at the end. So I would like to thank for the organizers for this very sorrowful order of presentations. Secondly, we heard a lot of presentations today about circularity, about the sustainable world, about things I think everybody in this room has really the goal to come to this. You will hear a presentation by myself, quite less technical, less solution-oriented, but very administrative. But anyway, I think I can get the link to this wish of everybody from us coming to a circularity. Research at universities of applied sciences. Why was I asked to give this presentation? Why was I asked to tell you something about how earning a doctorate from our university? When we go back in the history, my kind of university, Hochschule für angewandte Wissenschaft, we always had a very, very strong focus on teaching. When I took over my professorship about 25 years ago, I told my doctoral father that I will do this, that I will go to a Fachhochschule. And he told me, oh, congratulations to that new job, but remember always, at this kind of university as a Fachhochschule, they will burn you by teaching. Unfortunately, I'm not burned, but I'm still burning for teaching. And I think all my colleagues also burn for teaching. And when you're burning for teaching, then you always want to look also behind the things. Then you always have a kind of burning for research. However, that was not the focus of our kind of university. But since about the year 2000, the Hochschulgesetz promotes also research at our kind of university. And today, and this led to the fact that also we have a quite high load of teaching, that also many, many colleagues did this teaching. And today, this application-orientated research is increasingly strongly at our kind of university. And then with the high-tech agenda in 2019, there was the possibility to reduce the teaching load of our colleagues. And we today have the possibility of reducing the teaching load of about 1/4 of all colleagues by the half. So they have not only this kind of person, this force at my university, at OHM, we have about 100 colleagues which have this reduced teaching load, and which has now not only a teaching load, but also, of course, a research load. They have kind of contract with the university what they have to do. And all this shows that there is not this basic research like it is at the university, but that we have a very, very strong application-oriented research at our university. And I think that was clear that this led to the fact what happened with the Bayerische Hochschul-Innovationsgesetz, that this new law allowed our kind of universities to apply for the right to award doctorates, for the right to introduce a Promotionszentrum or doctoral research center. And what was this? This Bayerische Hochschul-Innovationsgesetz, as I said, it allowed the Hochschule für angewandte Wissenschaften to apply for the rights to award doctorates, not for the whole university, but in research-intensive areas. And now you can ask yourself, what is a research-intense areas? And this definition about what a research-intense area is also given in this Hochschul-Innovationsgesetz. There are two kinds of strengths in research. On one side, there is the institutional strength, which means that we have to have at least 12 research-strong professors. They have to be active in a coherent research space, a research area. They have to work together, and they have to have an adequate experience in supervising doctoral studies. And of course, these at least 12 persons have to have a personal strength in research, and there was clearly defined that these people have to have a minimum amount of acquired third-party funding and a minimum number of publications, depending a little bit whether they work in a technical or non-technical area. This was the Hochschul-Innovationsgesetz, and now it was the question for us, would we apply for this? Of course, we are one of the region's strongest University of Applied Sciences in Bavaria. We have to apply for this right. We have to apply for some doctoral research centers, for Promotionszentren. And we asked ourselves, would we do that alone, or would we do it with partners, with associates? And of course, doing it alone, it would be maybe something where you can show how strong you are at university. But we said, no, we won't do it like this. We will do that together with partners. We did it together with the Hochschule München and together with the Ostbayerische Technische Hochschule Regensburg. And we did it together with these partners because we wanted to have a real focused area in every Promotionszentrum. We wanted to have a real focus, not on something like we do a doctoral center about anything which is with engineering, or anything which is about non-engineering or something like that. We wanted to have a real focused thing, and thought this is better to do this with other strong partners. We wanted to have a deep cooperation with these partners. We wanted to bundle, of course, our research experience, our research activities, and of course we saw also some synergies on the administrative side when having these partners. And the boundary conditions were then that always one of our three universities had to apply for this doctoral center, and the others were partners in this application. We wanted to have an equal distribution of these doctoral centers, taking into account that there are local priorities and local research strengths. And then we ended now with these 7 doctoral centers. Again, I want to tell you, it's not that our whole university has the right to award doctorates, but all professoral members of these 7 doctoral centers now have the right to award a doctorate. We have 2 centers which are located in Nuremberg, a doctoral center in Energietechnik and a doctoral center in Materialien and Produktionstechnik. We have 2 which are located in Regensburg. It's applied computer sciences, and a doctoral center about social and health sciences in the way of transformation processes, both located in Regensburg, and 3 centers located in Munich, one about applied natural sciences, one about applied research for responsible innovations, the business sciences, and one about civil engineering. In any of these 7 doctoral centers, we have members of our university which are there. I will have a look on the 2 doctoral centers which we host in Nuremberg. One, and it's very nice to have it today here because again here you see this circle, this loop in our Center for Material and Production Technology, where we have research and doctorates along the entire value creation process over material sciences, process technology, production technology, and product development. These are the members which are from our university in this doctoral center. Maybe you know some of them. I think most of them already work together with Siemens or with colleagues from FAU. And the second one is our Doctoral Center for Energy Technologies, where we have the three main energy topics: electrical energy technology, chemical energy technology, and thermal energy technology. All three, of course, over the whole length from generation and transformation of energy over distribution and storage to the efficient consumption of energy. And of course, as fourth element, the connecting element of sector coupling. Also for this doctoral center, here are the members of this doctoral center. Maybe you also know quite a few of them. Our 7 doctoral centers, what are our hopes? What do I think? We hope at our university that these 7 doctoral centers will strengthen the research at our university. I'm quite sure that these doctoral centers also will strengthen the cooperation between our 3 universities of applied science, strengthen all these fields. And what we always hope is that it will increase the attractiveness for 2 groups of persons also here sitting here in this room, for young researchers, because from now on a young scientist beginning with his career at our university, he will not only have a very interesting topic, he will not only work in a project funded by public funds, he also will have the possibility that his professor or her professor will definitely be able to lead him to a doctorate. And secondly, I think we also, because of this fact, will be more attractive for industrial partners. These are my hopes, these are our hopes, but what I always want to give you is this sentence now, that from now on candidates can get their doctorates directly from, not only from Ohm, but also from our kind of university, from these persons being members of those doctoral centers. Thank you very much.
Well, I would also say thank you. I can't believe that I'm saying this, but we are at the end of our conference, at least what's happening on this stage. To close it off, I would really like to say thank you all. It was amazing to have you in the crowd. We had amazing speakers here, and I saw you networked a lot, so that makes me particularly happy. I do have information for the people who want to continue with cool activities. So the Siemens campus in Erlangen, they have a Lichterfest with a cool program and activities, so feel free to check that out as well. They are available, or they do this until Thursday next week. And now it's time to network, so that's what's happening here. And finally have some lunch and check out the marketplace if you haven't done it already in the breaks. Yeah, that is it. If you want to do a ZOLLHOF tour and get to know what we're doing, then we meet in this corner over there. And with that, I would like to thank you, and yeah, let's eat.